What's up, everybody? It's Dan from SageMathTutoring.com, and here we're going to have a pretty long video. I'm going to timestamp it below, but it features various concepts, mathematical concepts, up to like an 8th grade level or so, okay? And towards the end, there's going to be some harder problems that feature concepts that are probably a little bit past 8th grade level. So I say we dive right into it. First of all, we've got numbers, operations, and absolute value. Find the absolute values. Well, in this case, basically the rule with absolute value is whenever there's a positive or negative number inside the absolute value symbols, it's going to churn out and result in the positive version of whatever was in there. Now, 156 is already positive, so this is just going to become 156. For the as it pertains to the rules that I just said, this is going to become 97. You do have to be careful with this because this is a negative of the absolute value of negative 13. Now, the absolute value of negative 13 is just 13, so it's going to be a negative 13, and that turns into a negative 13. Okay, so you do have to be careful. The negative 13 inside the absolute values becomes positive 13, but then that negative is still out front and gets applied to the positive 13 at the end. So therefore, we're looking at negative 13. This next one, I would strongly recommend just rewriting, only applying the absolute value symbol to that negative 23. So we have this, and then that would become, I believe, 97, unless my mental math is off. This I would rewrite as 35 minus 12, right? Because that absolute value of negative 12 becomes positive 12, so we're looking at 35 minus 12. 35 minus 12 is most definitely 23. Okay, so that's how you do those. Order of operations, well, there is the whole PEMDAS thing, right? There's the whole PEMDAS. Now, when they say P, they mean parentheses, sure, but you could also say that that stands for brackets or absolute value symbols. All right. So basically any symbol that would group quantities together, that's what the P stands for. So in other words, you would have to actually figure out what's going on inside the absolute value symbols there. So you could always rewrite it as 100 divided by 5 plus, and then the absolute value of negative 5 times 3, which is negative 15. And that's going to become, we would want to apply the absolute value symbols upon that negative 15 first, because we're still sort of tending to the P in PEMDAS right now. So that could be rewritten as 100 divided by 5 plus positive 15, right? So it's plus 15. At that point, we have division and addition. Now, D comes before A. Division comes before addition. So we do have to divide 100 divided by 5 first. 100 divided by 5 is 20, and 20 plus 15 is 35. All right, so that's how you do that. This I would rewrite as 5 times negative, and it's literally just 9, right? Because when we apply the absolute value symbol upon this 9 in here, well, that just becomes 9, right? But then it's negative 1, it's ultimately negative 1 times. There's a little negative 1 there. It's ultimately negative 1 times 9, so it's really 5 times negative 9, and that's going to become negative 45. Now, that could be very confusing. Part of the reason it might be confusing is because there's this multiplication symbol that's the X. That's like the old school multiplication symbol. I think the real thought process, though, is you want to just realize, okay, well, it's negative absolute value of 9. Well, what is the absolute value of 9? Just 9. So it's really negative 9 here. So therefore, it's 5 times negative 9, and that's negative 45. This next one could be rewritten as 99 divided by 33. And that's going to equal 3, I believe, right? All right, so that's how you do that. Prime factorization of 60. Well, first of all, what are prime numbers? Prime numbers are numbers that are only divisible by themselves and 1, okay? So the first, few prime numbers would be 2. I'll actually list them vertically. The first few prime numbers in existence would be 2, 3, 5, 7, not 9 because 9 is divisible by 3, but 11, 13, and then it kind of goes down from there, it goes to 17 and so on, okay? So these are all prime numbers because the only factors of these numbers are itself and 1, okay? Notice how 2 is even. It's actually the only even prime number. It's also the first prime number, okay? A lot of people think 1 is a prime number and 1 is not a prime number, so you do have to be careful with that. Okay, so nonetheless, prime factorization of 60. When they ask for that, what they're really asking you to do is write the 60 up here and then create a factor tree. You do this little split thing and you ask yourself, is 60 divided by 2? That's the first, number in the prime number list. We're going to kind of ask that question down the list, but you always start at the top of the list. Is 60 divisible by 2? Well, yes, it is. So you're going to write a 2 there, and then 2 times 30 gives you 60, right? Now, once you have a prime number on the tip of the branch, then you don't need to work with that one anymore. So now we're going to look at this one, though. Is 30 divisible by 2? Well, yes, it is. So that becomes 30 divided by 2. I'll keep that in green. And then we have 15, right? 15. Now, once again, this 2 is already prime. We have 2 prime numbers at the tips of the branches, so we're going to leave them alone. So we have 15. Is 15 divisible by 2? Well, it's not. So then we ask ourselves the next number in the list. Is 15 divisible by 3? The answer is yes. So this turns into 3 and 5. Now, at this point, we have prime numbers at the tips of the branches, and therefore we are almost done with the prime factorization of 60. Once you get these, you're almost done. Now, the reality is what we just learned is that according to the prime factor tree, we have 2 times 2 times 3 times 5 would give you 60. Now, you could always double check that. You could always find out, does 2 times 2 times 3 times 5 give you 60? Well, you would quickly discover that it would actually give you 60. Now, typically the way they write that, though, is instead of writing it as this string of multiplication, they do write it as a string of multiplication, but what they tend to do typically is to make sure that if there's an opportunity to represent an exponent, then they'll do that. Now, the reality is that 2 times 2 is really 2 squared. So that's going to be 2 squared times 3 times 5. Okay, we're going to use these x's for multiplication symbols. Then that's what that would be. Okay, so that's how prime factorization works. Now, prime factorization is a different skill than the skill that's going to be required for the next 3 problems. This is a very specific skill. This specific skill has to do with the factor tree. This is a whole different thing. This is the greatest common factor. Now, the greatest common factor, in my opinion, the best way to do greatest common factor is to use what some people call the cake method, all right? So the cake method would basically ask you to put 20 and 30 right here, and you do this kind of upside down wedding cake deal. You ask yourself, what is a number that goes into 20 and 30? Just off the top of my head. Well, certainly 2, right? So you write 2 over here. Then you ask yourself, 20 divided by 2 is what? Well, that would be 10. Similarly, 30 divided by 2 is 15, right? And then you ask yourself, okay, well, what's a number that goes into 10 and 15? And you might say to yourself, well, definitely 5, right? That pops out as a possibility. So then I say, okay, 10 divided by 5, what's that? Well, 10 divided by 5 is clearly 2. 15 divided by 5 is clearly 3. And then you ask yourself, okay, is there anything that goes into 2 and 3? Well, 1 goes into 2 and 3, both 2 and 3. But if the answer to that question is 1, then you're actually kind of done with the cake method. Now, when you're trying to find the greatest common factor, you actually just work with the 2 side numbers and you multiply them. The 2 side numbers are 2 and 5. So 2 times 5 is equal to 10. All right, that's a method that will work every single time. We're going to try it again with problem number 3. So with problem number 3, we'll bring that down here. We're going to say, okay, 63 and 81, right? Well, what goes into both 63 and 81? Well, I'm thinking probably 3, right? 3 goes into both. 3 goes into 63 21 times. 3 goes into 81 27 times? Yeah. So then you ask yourself, okay, what's the number that goes into both 21 and 27? Well, 3 goes into both of those. So 3 goes into 21 7 times, 3 goes into 27 9 times. Is there any number that goes into 7 and 9 other than 1? No. The only common factor between 7 and 9 is just 1. So therefore, we're looking at these two numbers here, and certainly 3 times 3 is equal to 9. Okay, so that's how you do that. Now this one, they're asking for the least common multiple, the least common multiple. Now, the least common multiple, you could actually do the cake method again, which is awesome. And you go through the motions with the cake method. You would get the 3, 21, 27. In fact, we just did this, right? You'd have another 3, and then you've got your 7 and your 9. Now, the thing is, though, with the least common multiple, you just do the upside down wedding cake method, but then it's a little bit different. This time, you're going to be multiplying these numbers. Okay, you're going to be multiplying these numbers. So it's going to be 3 times 3 times 7 times 9, actually. So it's actually a large number. 3 times 3 times 7 times 9. And that is 567. Okay, so recap. Prime factorization requires the factor tree. GCF requires upside down wedding cake, except you're working with the side numbers, and least common multiple is the upside down wedding cake with the side and the bottom numbers. Okay, fractions. Let's take a look at this. Well, when you have a common denominator, it's actually relatively easy to subtract them. You're going to keep the denominator and subtract the numerator. So it's 4 minus 7, that's negative 3. So that's negative 1/3 if you were to reduce that, okay? So you might want to reduce those, right? You might want to recognize, oh, 3 and 9, they have a GCF of 3. I could divide 3 by 3 and get 1. I could divide 9 by 3 and get 3. Now, this said negative 3 over positive 9. I'm writing it as a negative sort of off to the side here. Just know that that's okay. Negative 3 over positive 9 is really negative 1/3. So you can put the negative symbol to the side of that fraction symbol, that fraction line there, okay? Let's see. Over here, we would want to perhaps rewrite it. And what we'd want in that case is to get a common denominator. The common denominator candidate would be 30 because 15 goes into 30. 15 times 2 is 30. So you're going to want that common denominator. So this is going to become 30 down below, but you're going to have 16 up top. You're going to have 30 down below here. You're going to have 9 up top. So then you have 25 over 30. That can also reduce to, what would that be? That would be both divisible by 5. So it's a 6 down below and a 5 right there. Okay, so that's how you do that one. So for the next one, different teachers might have different ways of approaching something like this. I would say turn these into improper fractions first. So in order to do that, you would go 4 times 2, which is 8. 8 plus 3 is 11. So this is really 11 over 4 minus something. And then we have 4 times 3, that's 12. 12 plus 2 is 14. So we're going to have 14 right there. Now, we already have the common denominator, which is great. So really all we have to deal with is 11 minus 14. And that's going to become negative 3. And then we have 4 right there. So that's going to become negative 3/4. Okay. So with mixed numbers, you might want to turn those into improper fractions. Turns out multiplying fractions is relatively easy compared to adding and subtracting, because the reality is you could just go straight across. You could say 7 times 3 is 21, 9 times 4 is 36, and then you would have 21 over 36. However, if you want to be a little bit more advanced, you can realize that that could turn into a 1 and cancel with that. That could turn into a 3. You could almost treat it as though 3 is already over 9. It's like 3/9. What would that reduce to? Well, that would reduce to 1/3, okay? That's a way of kind of making your life easier. You could do this diagonal cancellation stuff. Turns out you can't cancel 7 and 4 here, so you're kind of stuck with that situation. But once you've done this cross cancellation scenario, it's a little bit easier to just multiply straight across. You can have 7 times 1, which is just 7. You're going to have 3 times 4, which is just 12, and then you're done. Now, if you've done that cross cancellation properly, like from the get-go, you actually don't need to reduce at the end. It will be a fully reduced answer. Similarly, I would once again do that improper fraction stuff. 3 times 4 is 12. 12 plus 2 is 14. So we're going to have 14 over 3. It's really 14 divided by 6. Now, 6 is secretly 6 over 1. Let's just keep that in mind. There's secretly a little 1 under there. Now, what we have in our hands here is two fractions being divided. We have one fraction divided by another fraction. I know it's an improper fraction. I know that this is a fraction with 1 as a denominator, so it's kind of weird. But at the end of the day, it really is two fractions. You have a fraction divided by another fraction. That's the reality of it. And we could say they're both improper. So what do you do when you have two fractions that you're dividing? You're dividing one fraction by another fraction. Well, you keep the first thing, you change it to multiplication. I'm going to use an asterisk. And then you flip the second thing. So you have 1 over 6. So you multiply the first thing by the reciprocal of the second thing. So it's 14 over 3. 14 over 3 times 1/6. Now, once again, we could do a cross cancellation. That turns into a 7. That turns into a 3. At that point, we can multiply straight across. We have 7 over 9, and we are done. Okay. Over here, keep the common denominator. No big deal. 6 plus 3 is 9, so we're done with that. That's an easy one. I'm going to rewrite this one. We have 1/4 plus 2/7. The denominators are not the same. We have to find the common denominator. 28 is the least common multiple of 4 and 7. So whenever you need a common denominator, what you want is the least common multiple of the two denominators. Now, we could always use the upside down cake method to find the least common multiple, or we could just realize, oh, it's clearly freaking 28, okay? Least common multiple is 28, so I have to multiply this by 7, the top by 7, okay? And I have to multiply this by 4, and the top by 4, okay? As a result, that becomes 7 over 28 plus 8 over 28, and then we have 15 over 28, and then you are done. So that's that one. Next one's fairly easy because the denominators are the same, which is awesome. We're going to have 17, and then 10 minus 6 is 4, and then we are done with that. That cannot reduce. Over here, let's see. What do we have? 3/4 minus 2/5. Okay, well, I'm going to rewrite that one as well. 3/4 minus 2/5. The least common multiple of the denominators will be 20. So we're going to have to multiply this by 5 in order to get that 20. We're going to have to multiply the top by 5. We're going to have to multiply this by 4. We're going to have to multiply this top by 4. As a result, that becomes 15 over 20 minus 8 over 20. And that would be 7 over 20, and then you are done with that. Okay. Going to rewrite this one. Actually, do I need to? No, I don't need to. This is multiplication. Now, once again, you could multiply straight across. 2 times 9 is 18. 3 times 13 is, 33? You could do that, and then you could reduce, or you could realize that turns into a 1, and that turns into a 3. 2 times 3 up top is 6. 1 times 13 is just 13, and then you're done. Okay, looking at the next one. Which fraction is greater, 5/9 or 7/12? So a good way to tackle these is to just force them to have a common denominator and then compare the numerators. So 5/9 and 7/12. Well, what is the least common multiple of 9 and 12? Well, for that, I actually would want to use the upside down cake method. 3 goes into both of them. 9 divided by 3 is 3. 12 divided by 3 is 4. And then we are kind of stuck with this situation because 3 and 4 do not have a common factor other than 1. So we're looking at these three numbers sort of here and down below. We can multiply. That's 3 times 3 times 4. That's going to be 9 times 4, which is 36. So the least common multiple of 9 and 12 is 36. So what we want to do is go ahead and multiply this by 4 and the top by 4. We're going to multiply this by 3 to get that 36 and the top by 3. And then we're just going to compare the numerators. So we have 20 over 36, and then we're going to have 21 over 36. Clearly, this numerator is larger, so therefore 7/12 is bigger than 5/9. Okay, So 7/12 is the answer. Convert 19 over 5 into a mixed number. Whenever you convert an improper fraction into a mixed number, you're going to have to bust out the old long division stuff. We are looking at 19 divided by 5. 5 goes into 19 three times. 5 times 3 is 15. 19 minus 15 is 4. So we have this remainder of 4. So what do you do then? Well, you realize that this number becomes the big number, okay? And then you're going to have the 4. You're going to have the 4, which is the remainder, and then the divisor is 5 right here, okay? So the number up top becomes the big number, the remainder becomes the numerator, and the divisor remains, we could say the divisor down there remains the denominator. Notice how 5 was the denominator before, it's still the denominator, okay? Convert this to an improper fraction. Well, we already kind of did that before. That's going to be a matter of 8 times 6 plus 5. So 8 times 6 is 48. 48 plus 5 is 53, I believe. And then we have 8, and then we are done. That's how you do it. 8 times 6 is 48. 48 plus 5 is 53. Stick it over the 8. And then you're write the following numbers as decimals. Okay, 23 and 78 1/1000ths. Okay, so the fact is that anytime they give you a mixed number and they want you to convert it into decimals, right? Anytime they have a mixed number and you convert it to decimals, that would be such that the large number is the number in front of the decimal. Now, the 1000 means there's going to be 3 placeholders, okay? So I want you to think of the fact that there's 3 zeros here as associating with 3 placeholders, and then the 78 goes towards the end, which means we need the 0 as a filler right there, okay? That's the thought process, okay? So that's that. 17 hundredths, well, there's a 0, and since it's hundredths, there are 2 zeros in 100, so that means there's going to be 2 placeholders, and apparently it's 17, so we're going to have 17 right there. That's how that one works. When you add these, well, you could stack them actually. So that could be 34.7 plus 4.1, and then we have this 0.3 here. Okay, notice how I am stacking the decimals. Okay, I'm doing this stacking addition situation, but notice how the decimals are on top of each other. You have to do that. Now, it is the case that there's this invisible 0 here, this invisible 0 here, so you're going to want to take those into account. So we're looking at 3, 7 plus 1 is 8, drop the decimal down, 4 plus 4 is 8, and then we have that 3 right there. So that is the answer to that one. We could do a very similar process here. We're going to stack it, so it's 125.05 minus, and we know that there's going to be a 0.4, so I'm just going to write that, and we have the 11, so I'm going to write it like that. Notice how I prioritize the decimals being one on top of the other. Let's also put our little placeholder here, right? We're going to want that placeholder right there. So then we're subtracting. 5 minus 0 is 5. This is going to become a 10, and that's going to drop down to a 4. So we are now looking at 10 minus 4, which is 6. Let's drop the decimal. 4 minus 1 is 3. 2 minus 1 is 1, and then we just have 1, and then we are done with that one. This one right here, I would stack it actually, 5.34 times 10. Now this is multiplication, so it's a little bit different. We're going to multiply everything times the 0 first. So 4 times 0 is just 0, 3 times 0 is 0, 5 times 0 is 0. Then we need this 0 as a placeholder. Now we're going to multiply all these top numbers to 1. 4 times 1 is just 1. 3 times 1 is 3. 5 times 1 is 5. And then you're going to add these two guys. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 3 is 3. And then we just have the 5. Now, at this point, you count how many total decimal places there are. There is 2 decimal places here, right? So that means you're going to count over 1, 2 decimal places, and you're going to put a decimal right there. All right, that's the thought process. So the final answer should be 53.10, also known as 53.1. Okay, dividing. I would use long division, so we're looking at 4.9 going into 245. Now, the problem is, though, you are not allowed to have a decimal in the divisor. You can have a decimal over here, but you're not allowed to have a decimal over here. So basically what you have to do is you have to move it over 1 unit. You have to move it over 1 like that, which means you got to take this invisible decimal and move it over 1, which requires you doing a placeholder right there. So therefore we could rewrite it as 49 going into 2450. Okay, that's what you're going to want to do with these. Anytime you have a decimal in the divisor, you have to kind of do this moving it over, but you have to move it over there too, and then you just take it from there. Now 49 goes into 245. I don't know. What is that? Five times probably, right? Yeah, so 5, you're going to put the 5 here. So 49 times 5, I think it's literally 245. So you can subtract that. You're going to get a 0, drop that 0 down. 49 goes into 0 times. If you want to be very thorough, you could be like 49 times 0 is 0. And then you subtract these and you have a 0, and then you are done because that's a remainder of 0. Anyway, quotient is 50, and that is the answer. Okay, ratio and proportion. Let's see. On a beach, the ratio of boogie boards to surfboards is 12:3. If there are 84 boogie boards, how many surfboards are there on the beach? Well, I would say let's put the boogie boards over the surfboards. Okay, you got to make that decision first, and then you just represent the relationship that they told you. It's 12:3. Okay, now you're going to set up a proportion where that's going to be equal to a certain amount of boogie boards. We'll call that. Well, we'll say that that's 84 because that's what they told us, but we don't know how many surfboards there are. Okay, so there are 12 boogie boards for every 3 surfboards, but it's the case that we have 84 boogie boards. How many surfboards do we have? Well, you're basically just going to rely on this structure here. And the beautiful thing about that is you could just cross multiply. So it's going to be 12 times x, which is just 12x, okay? And then it's going to be 84 times 3, which is 80 times 3 is 240. 4 times 3 is 12. 240 plus 12 is 252. Okay, so what did I do? I multiplied these two, and I got this, and I multiplied these two, and I got that. That's what I did. At this point, we're going to now divide both sides by 12. Okay, and we have x equals 252 divided by 12 is, let's see, that would be 21. Okay, so we just learned that if it's the case that we have 12 boogie boards for every 3 surfboards, well, therefore, if we have 84 boogie boards, we must have 21 surfboards. That's how you tackle those. All right, looking at problem number 2. There are 48 people on a camping trip. 16 are female. What is the ratio of male to female? Well, let's see. Well, the good news is you can kind of see that if 16 are female, clearly 48 minus 16 are male, right? 8 minus 6 is 2, 4 minus 1 is 3, so 32 male, all right? So we want to know what's the ratio of male to female? Male to female. Well, let's put the literal number of males, 32, over the number of females, and at that point, you could just reduce. You could just reduce it like a normal fraction. That would be 2 to 1, okay? 2 to 1. So that's, we could say, the ratio. And there are really at least 3 ways of expressing that information. You could express it as a fraction like I just did, 2 to 1, or you could say literally 2 to 1, or you could say 2 to 1, keeping in mind that the first number represents males, second number represents females. First number represents males, second number represents females. Okay, so that's that. 2 numbers are in the ratio of 5 to 8. If the larger number is 72, what's the smaller number? Well, once again, we could say So we'll put the smaller number up top. We'll say S over L, small over large, okay? And therefore 5 over 8, and we're going to set that equal to, the larger number is 72, so we're going to put 72 down there, and X is the unknown. So once again, we will be cross-multiplying, okay? We'll be cross-multiplying, and therefore what we're looking at is 5 times 72. Well, that would be, 350 plus 10, 360, and then we have 8x, right? I'll keep that actually in yellow, 8x. So at this point, divide both sides by 8. 360 divided by 8 is 45 if you were to work that out, okay? So hopefully that makes sense. Let's see. A set of dollhouse furniture is made to scale and is 1/72th the size of real furniture. It has a scale of 1/72, okay? If a real table is 6 feet in length, what is the length of the corresponding dollhouse table? So there's the dollhouse and then there's the real, okay? There's the dollhouse size and then there's the real. So apparently the dollhouse is 1 unit for every 72 units of real, okay? That's essentially what this means when they say it's made to scale and is 1/72 the size of the real furniture. What that means is for every 1 unit of length, we could say the dollhouse is, the real one is 72 units of length, so that's one way of looking at it, all right? If the real table is 6 feet in length, okay, so apparently that's 6, what is the length of the corresponding dollhouse table? Okay, in that case, X is the dollhouse length in this case, right? So once again, we will be cross-multiplying, and then we have 72x equals 6. X therefore equals 6 divided by 72. And 6 is divisible by 3, that's 2. 72 is divisible by 3, that is 36. Both of those are divisible by 2, so that's going to be 1 over 18. Okay, so that's the answer. And that kind of makes sense. So basically, if the real table is 6 feet in length, well, the dollhouse is 1/18th of a foot in length. Okay, so once again, dollhouse over real, we had that relationship. You set it equal to x over 6 because the real table is apparently 6 feet in length, okay? And then you solve for x by cross-multiplying. Okay, looking at strawberries are 3 quarts for $4.98. How much will 10 quarts of strawberries cost? So we will put money up top and we'll put quarts down below, okay? Now you could have done vice versa as long as you're consistent all the way across. So apparently it's $4.98 for every 4 quarts or 3 quarts. And then they're asking, okay, well, how much for 10 quarts, right? How much for 10 quarts? So therefore 10 would be on the bottom and x would be on the top. So cross multiplying, we'd have 3x equals 49.8. And then dividing 49.8 by 3 would give you 16.6. Okay, so also known as $16.60. All right, fill in the following chart with the decimal and fraction equivalent to the given percent. More than one response may be correct. The first has been completed for you as a guide. Okay, so when you see 25%, you could actually write 1/4. You could also write 0.25. So converting percentages to decimals, let's just start there actually, because that's the easier part. They just wrote 0.25 off to the right. So we're going to kind of fill out the decimal column first. All you have to do is move the decimal place twice to the left. So that becomes 0.32. You can put a little 0 in front. This is going to become 0.880 or 0.8. This is going to become 0.95. This is going to become 1.5 actually, and this is going to become actually 5. Okay, I know that's kind of weird, but 500%, that's more than 1. That's more than 100%, right? So more than 1, so it's 5. all you have to do to convert to a fraction is just put 32 over 100, and that's going to reduce. We'll get to that later. This is going to be 8 over 100. That's also going to reduce. So that's all you have to do ultimately with converting percents to fractions. You just put it over 100 and then reduce. We're going to reduce later though. 95 over 100, 150 over 100, and then 500 over 100 now. 32 over 100 is going to be 16 over 50, also known as 8 over 25. 80 over 100 is 8/10, also known as 4/5. 95 over 100, 95 divided by 5, what is that? 95 divided by 5. 5 goes into 9 once. 5, we have 4, 5, 19. Okay, so we're going to have 19 over 20 in that case. This is going to be 15 over 10, also known as 3 over 2. This is going to be 5 over 1, aka 5, but we'll just call it 5 over 1 as the fraction. So to reiterate, converting percents to decimals is easy. Just take the decimal place, move it twice to the left. That's what they did here. Converting percent to fractions, also halfway decently easy. All you have to do is just put a 100 underneath the number, and then you're good to go, although you do want to reduce if necessary. So that's that. Looking at what is 50%, 57% of 350. Well, there's really a couple different ways of going about that. One is to do this part over whole method, which I think I'm going to stick with because in my opinion, that's like the least confusing way to take care of it. So it's going to be part over whole equals percent over 100. So in this case, the part we don't know, okay? So that's going to be x. The whole we do know, it's 350, and apparently that's going to be 57% over 100, and then at that point you can cross multiply, okay? You can cross multiply. So as a result of cross multiplication, you're going to have 100x equals 57 times 350, which is 19950, and then dividing both sides by 100 would be 199.5, and that's the answer. Let's see, what percent of 200 is 68? Well, the part is 68 in this case, the whole is 200, and the unknown is the percent, so we're going to put x up there, and then we have 100 down below, always 100 down below on the bottom right-hand side of this proportion. Then we can cross multiply. In doing so, you would have 6,800 equals 200x, dividing both sides by 200 would be 3200, and then you are done. That's it. 19 is 76% of what number? So 19 is the part in this case. The whole is the mystery, that's x. We have 76 over 100. So then we can cross multiply, and as a result, we would get 1900 equals 76x. Dividing both sides by 76 would give me 25. Okay. 2 out of every 5 members of the after-school club are male. What percent of the after-school club is male? So that's sort of a proportion, but the good news is you can really use this structure again. 2 out of every 5, right? So you can say 2 out of every 5 equals some percent over 100. And then you could just cross multiply from there. You're going to have 200 equals 5x, dividing both sides by 5 gives you 40. Okay, so therefore we know that what percent of the after school club is male? Well, 40% of the after school club is male. That's how that works. Problem number 5. Hockey sticks that normally sell for $89 are on sale for 35% off the regular price. There's also a 6% sales tax. How much will the stick cost after the sale and the tax? Okay, well, so the thing to remember is that you're going to want to apply the discount first and then apply the tax to the discounted price, okay? So in other words, what is the reduced price, right? Because it was 89, but then it's 35% off of 89, okay? Now the real question therefore is, what is, well, let's put it this way. All right, now you don't have to do this every time, but one way of thinking about it is that this whole thing is $89, right? Whole thing. And then we took off 35%. All right, we got rid of that part. So now we're left with the yellow part. Well, what percent is that? What percent of 89 is that? Well, that would be 65% of 89. Right? That's what we're left with, 65% of 89, because we took away 35% of 89, so we're left with 65% of 89. So then the question is, well, what is 65% of 89? Because whatever that is, whatever 65% of 89 is, well, that's going to be the reduced price, right? That's going to be the reduced price. So we could say part over whole, we could say x over 89 equals 65 over 100, right? Does that make sense? Hopefully that makes sense. Cross multiplying gives me 100x. 65 times 89 is 5785. All right, 5785 divided by 100 is just a matter of moving the decimal place twice to the left. We have 57.85, $57.85. So that's the reduced price after they gave you the 35% discount. So then we're going to apply the sales tax to that, right? So then the question is, well, what's 6% of this new number, right? Well, the part in this case is the mystery. The whole is 57.85. We know we're looking at 6% of that, so 6 goes up there. We're going to have 100 down there. At that point, we can definitely cross multiply. We're going to have 100x equals 6 times 57.85, which is 347.1. And then we have both sides divided by 100 is a matter of moving that decimal twice to the left. That's going to be 3.471. Now, that's the tax, right? That's the tax amount, right? It's $3.47. So what you're going to do is you're going to add $3.47 tax to that reduced price. 5 plus 7 is 12. Carry the 1. 8 plus 4 is 12. 12 plus 1 is 13. Carry that one. Drop the decimal. 7 plus 3 is 10. Plus that extra 1 is 11. Carry the 1. 5 plus 1 is 6. So $61.32. So just to recap, that was a challenging one, right? Kind of challenging. Just to recap, they said, oh, that used to be 89, but then it's 35% off, also known as 65% of the original price. 65% of the original price turned out to be 57.89. We did the whole, found out 65% of 89, right? 89 was the whole. The part was the mystery. We found out that 65% of 89 is 57.85. But then we have to apply a 6% sales tax to the reduced price. Well, we had to find 6% of 57.85. So we put 57.85 as the whole. The part was the mystery in this case. The 6 goes here. We have the 100. We used cross multiplication. We realized that x equals $3.47 approximately. Obviously, there's this little 1 here. But we have $3.47. We added $3. That is the sales tax, by the way. That's how much money you have to give the government, basically. So you have $3.47 plus that reduced price gives you $61.32. So that's how that one works. Okay, looking at problem number 6 now. Let's see. The book club attendance rose from 25 to 30 members. What is the percent increase in membership to the nearest percent? Okay, now they're dealing with percent increase. I would strongly recommend new amount minus old amount all over the old amount times 100, and that equals percent increase or decrease. Okay, now, if this whole structure leads to a positive number, it's going to be a percent increase. If this whole structure, when you work it out, turns into a negative number, that's going to be a percent decrease. Either way, it's going to produce a number, and that's going to be the percent, okay, increase or decrease. So it used to be 25, but then it went up to 30. So the old amount is 25, but the new amount is 30. So that's going to be 30 minus 25 all over 25 times 100. And that's going to be equal to what? Well, let's see. We have obviously 30 minus 25 is just 5. 5 over 25 times 100. And that's going to be 1/5 times 100. 1/5 of 100 is 20. Now, in case that's not clear, you could always just put a little 1 underneath and literally multiply straight across. You could also cross cancel. That becomes a 20. That becomes a 1. And when you multiply straight across, you can have 20 over 1, aka 20. So basically what we realize is that when we do the new amount minus the old amount all over the old amount, we get a 20%. So that's a 20% increase. 20% increase. All right, notice how since 20 was a positive number, it's a 20% increase. Had 20 been a negative number, it would have been a 20% decrease. All right, number 7, out of the 28 selections on the menu, 4 of them are desserts. What percentage to the nearest tenth of the menu are not desserts? Well, how many things are not dessert? Well, it would be 28 total selection minus the 4 that are desserts, right? 28 minus 4 is obviously 24, right? 28 minus 4 is 24. So the question is, what percent of the menu are not desserts? So it's going to be 24 is the part over 28 is the whole, and then X is the percent mystery, and then we have 100. So cross multiplying gives us 2400. 28x dividing both sides by 28 would give us really 85.714, but it's to the nearest tenth, so we're just going to say it's 85.7. Okay, so that's how you do those. Okay, find the mean of the following data set. So in other words, what's the average of this? Whenever they say mean, what they really mean is the average. They're really asking for the average. So let's see. That's a matter of realizing how many numbers you're dealing with. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total numbers. So we know it's going to be a matter of adding all of that and then dividing by 8. So it's going to be 32 plus 34 plus 34 plus 35 plus 37 plus 38 plus 34 plus 42. All divided by 8 at the end of that process. And when you do that, it's going to become 35.75. Now, once again, that was a result of adding everything on the top. And by the way, when I did that, that turned into 286. And then 286 divided by 8 is 35.75. Okay, what's the mode? Well, mode is basically the number that shows up the most. Well, let's see. We definitely have 71 showing up here and here. Do we have any other number that's showing up a lot? Well, actually, yeah, we have 68 showing up twice. 77 only shows up once, 65 only shows up once, and 72 only shows up once. So actually, we have 2 modes. So basically, it is possible to have more than one mode, okay? We have 2 numbers that show up twice, right? 71 and 68. So that's that one. Okay, the ages at the day camp were as follows, blah, 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 blah. What is the median age? Okay, well, first of all, when they ask you for the median, unlike the mode, unlike the mean, you are definitely going to have to put everything in order. So the smallest number is 8, right? So then the next number up is 9. And then we have another 9, don't we? And then we have another 9, don't we? All right. Then we have 10. Boom. Then we have 12. Get that out of here. Oh, we have another 10. Ooh, we have another 10. So we have another 10, which is right there. And then we have that 12. And then we have a 13. And then we have a 17, right? So these are the same numbers, only all listed in order. And the median is the middle number. Okay, now how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 total numbers. So the middle number has to be the fifth number. Okay, 1, 2, 3, 4, 5. So it's got to be that one. Okay, in case that's not clear, since it's an odd amount of numbers, okay, you know, 9 numbers in this case, you should have 4 flanked on the left, 4 numbers flanked on the right. Therefore, this is the middle number, okay? And that is literally the answer. It's 10. Okay, now the question might be, well, what would I have done if it was an even amount of numbers? Well, if that's your question, it's a good question. Imagine you had an even amount of numbers. Maybe they were written in order. Maybe it looked like that. Well, that's 6 total numbers. Well, what you would do is you would then take the middle 2 numbers. Okay, that's the third and fourth number. You would find the average of those. That's going to be 7 plus 10 divided by 2. And that's 17 divided by 2, aka 8.5. That would have been the median for this list of numbers. So anytime you have an even amount of numbers, you just take the average of the 2 middle numbers, and that's going to give you the median of that list of numbers. All right, what is the range of temperatures listed? Well, you could always list it in order. Order does kind of matter as well when you're considering the range. However, the range really only concerns itself with the smallest and the largest number in the list. So what is the smallest number? 42, right? So then what's the largest number? 78, 84. So when they ask for the range, what they're really saying is, what's the difference between the smallest and largest number? We could say, what's the difference between the largest and smallest number? Well, that's going to be 84 minus 42. It's very straightforward. Simple as that. 4 minus 2 is 2. 8 minus 4 is 4. Boom, 42. Done. Okay, let's see. Use the pictogram to answer the following questions. Okay, repairs required during the first 3 years for MP3 players per 100. Okay, so it's very important to recognize that a single one of these little boxes means 5 sets. Okay, these are all the brands, okay, and a single little box represents 5 sets. So when they say how many more brand A MP3 players per 100 needed repairs during the first 3 years than brand T. Okay, so they keep saying per 100, per 100. Well, the whole thing is per 100. This is a graph or a graph or a table or whatever you want to call it that is representing per 100. So they're being annoying by writing per 100, okay? They're just saying you use the darn chart and then analyze it, and that's all, okay? So how many more brand A are there than brand T? Well, brand T is right here and brand A is right here. So brand T has 4 right there. We have 4 here. But how many extra for brand A? We have, looks like it's 6 extra. Now, you might be tempted to be like, okay, well, the answer is 6. There's 6 more. But remember, each of these little boxes represents 5 sets. So that's going to be 5 times 6, right? So that's 30 sets more. Okay. Let's see. What percent of brand Z's MP3 players needed repairs during the first 3 years? Okay, this is, since they're mentioning percent, that's a part overhaul scenario. Since they're talking about percent, that's when we are going to be paying attention to the per 100 thing. The reality is brand Z is over here, right? Brand Z is this red one. And 1, 2, 3, 4, 5, 6, 7, 8. There are 8 little boxes, which corresponds with 40 sets. 40 sets. So that's 40 sets over 100 sets. And then the question is, what percent is that? Well, that's 40%, just obviously, right? Anytime you have a fraction where 100 is the denominator, the numerator could be construed as the percentage as well, okay? So 40%. Number 5, how many more brand Z MP3 players were sold than brand P during the 3 years? Okay, so this is a trick question because there's no mention of sales. There's only mention of stuff needing repairs, but we don't know how many were sold. So that's a trick question. That's a dumb question. They should be fired for even making that question. Okay, there is no answer to that question. You could say there's not enough information. Stem and leaf plot. Basically, the way to do this is to take note of the in this case, tens digits. All right. And just ask yourself, well, what numbers are sort of represented for the tens digits? Well, there's definitely a 1 represented, a 2 represented, a 3, a 4, and a 4, right? I mean, we see a 1 right here and here. We see a 2 right here and here. We see a 3 right here and here, and here and here. We see a 4 here, here, here. So what you do is you just write those, okay? But then you do this little thing where you then write the units digits, okay? So the units digits as it pertains to the tens digit of 1 would be these. Pardon me. The units digits as it pertains to the tens digit of 2 would be these. The units digits as they pertain to the tens digit of 3 would be the purple ones. And finally, the units digits as they pertain to the tens digit of 4 would be the brown. Okay, so we'll keep it color coded. We'll start with the green. We're looking at 2 and 3, so it's going to be 2 and 3. All right, see how that works? And then for the 2, we'll keep it color coded. That's going to be yellow. That's going to be 1 and 7. With regards to the units digit associated with the tens digit of 3, that's the purple one. We will keep it color coded. We're looking at 3, 4, 5, and 7. And then finally, brown for the units digits corresponding with the tens digit of 4, and that will be 0, 0, and 1. And I don't know why I drew this guy right here. That's extra, so I apologize for that. But anyway, that's how you do these. Now, you don't have to color code it, right? You don't have to color code it, but it can help if you have colored markers or something. But I just want to sort of illustrate the concept. The tens digits, in the whole list are represented here, and then you just, list the units digits here. Now, one reason they use stem and leaf plots like this is because you can clearly see what the longest row is. It's this one. So there's more data that's in the 30 to 40 range than any other data. And sometimes that's hard to see if you just have a long list. But if it's represented in a stem and leaf plot, you can clearly see there's clearly a lot of data as it pertains to, in the 30s. Okay. So that's how those work. Variables, expressions, and equations. Let's see, 4 times the sum of a number and 2 equals 48. So it's 4 times, if we're going to write that as an expression, it's going to be 4 times the sum of a number, so it's going to be n plus 2, and that equals 48. That's how to write that situation. 4 times the sum of a number and 2. Well, the sum of a number and 2 is right here, and it's 4 times that. So that's going to be 48. They say evaluate the following expression using the numbers given. Okay, well, first of all, let's simplify this because it's going to be a lot easier if we just realize, oh, this is literally just 3x plus 10. Okay, 3x plus 10, because these are like terms, so you could just combine it to 3x plus 10. Now notice, this is not an equation, this is an expression. It's not like 3x plus 10 equals something, and therefore we could just solve for x, right? But this is an expression, and what you can do when they say, what evaluate it when x is negative 1? Well, in other words, substitute negative 1 in for x. So in this case, it would be 3 times negative 1 plus 10, and that is going to become negative 3 plus 10, aka 7. Over here, it's going to be 3 times 5 plus 10, and that is 15 plus 10, which is 25. All right, that's how you do those. Solving equations. Okay, 3a plus 4 equals 13. Subtract 4 from both sides first. You end up with 3a equals 9. Divide both sides by 3. You get a equals 3. That is that one. 2p plus 2 equals 16. Subtract 2 from both sides. It's going to be 2p equals 14. Divide both sides by 2. P equals 7. Over here, we have 4 times c minus 1 equals 12. Well, there's a couple ways of going about this, but the most popular, or at least the way that many teachers would maybe insist upon in the beginning, is to go ahead and distribute. You're going to have 4c minus 4 equals 12. You're going to add 4 to both sides. You end up with 4c equals 16. Divide both sides by 4. C equals 4. You are done with that one. Let's see. This one, rewriting 10w plus 14 minus 8w equals 12. Okay, well, first of all, you always want to combine like terms whenever you can. So we have 10w minus 8w, and that's going to become 2w plus 14, and that's going to equal 12. Subtracting 14 from both sides, 2w equals negative 2. Divide both sides by 2, w equals negative 1. Okay, great. Over here, let's see. We have 3 times y minus 9 minus 2 equals negative 35. Maybe go ahead and distribute. 3 times y is 3y. 3 times negative 9 is negative 27. We still have that minus 2 hanging out, and we have that negative 35. Combining the like terms, right? Combine those like terms. It's going to be 3y minus 29 equals negative 35. Adding 29 to both sides would give us, I believe, what, 6? And then divide both sides by 3, we're going to get y equals 2. We are done with that one. Now looking at number 18. Number 18 says 4q plus 12 equals 16. Subtracting 12 from both sides. 4q equals 4. Divide both sides by 4. Q equals 1. And then finally, number 19, t over 5 minus 3 equals negative 9. Well, you can clear the fractions by multiplying literally everything by that denominator of 5. That's a decent way to go, in my opinion. Multiply everything by 5, because when you do that, it cancels this denominator here. So it leaves me with just a t right there. But then 5 times negative 3 is negative 15. And then we have 5 times that negative 9. Well, that's going to become negative 45. So you might want to do that when you have annoying denominators. You can literally just multiply all the numbers by that denominator, and in doing so, that 5 that you multiplied everything by knocks out the denominator, and it neutralizes it. It actually turns it into a 1. I mean, that's the reality of it. That turns into a 1. That turns into a 1. And t over 1 is just t. All right, at this point, we could add 15 to both sides. We're going to have t equals negative 30. Boom. That's that one. Okay, draw the solution set of x is less than or equal to 4 on the number line. Okay, so the critical value is positive 4, and we know it's going to be a closed circle. And the reason we know it's a closed circle is because there's an underline underneath the inequality there. Now, whenever the variable is on the left, you could actually treat the inequality symbol like an arrow, and it's going to be pointing to the left in this case. So we are looking at an arrow pointing to the left. What inequality is represented by this graph? Well, the critical value is 3, so maybe just write that. It's an open circle, so whatever the inequality symbol is it's going to be without the underline. And we also know that, we're dealing with x, we could say, right? X is, they used x as a variable before. Why not use it now? Which direction is the arrow pointing? Well, it's pointing to the right. So you're going to go like that. And that is a smart way of going about it. Critical value, variable, open or closed circle, take that into account. And then ask yourself, which direction is the arrow pointing? The arrow's pointing to the right, so this little point thing is going to be pointing to the right, okay? What is the solution to the inequality? 3x is greater than 9. Well, you could actually treat this like a regular old algebra problem. The only thing you need to be careful of, and I could already see they're giving us a problem like that next, but anytime you multiply or divide both sides of the inequality, you have to change the direction of the inequality symbol, okay? But in this case, you're just dividing both sides by 3, right? Cancel. Next thing you know, you have x is greater than 3, and then you are actually done. The reality is we divided by a positive number in that case, so you don't have to change the direction of the inequality symbol. All right, so that's the answer to that one. This one is trickier. Okay, this one's trickier. Negative 6a minus 4 greater than or equal to 8. Adding 4 to both sides, you get negative 6a is greater than or equal to 12. But at this point, we are now dividing by a negative 6. We're dividing by a negative 6. So the next thing you know, we're going to have a is not greater than or equal to. It's going to be less than or equal to negative 2, and then you're done. Notice how we changed it from greater than or equal to less than or equal to, and the reason is because we divided by a negative number. Anytime you divide by a negative number, you have to change the direction. Same rule applies for if you were multiplying both sides of the inequality by a negative number, okay? If you divide both sides of an inequality by a negative number, or if you multiply both sides of an inequality by a negative number, you're going to have to change the direction of the sign. Whenever they say compound inequality, what they're basically saying is you could just stick x in the middle, put one critical value over here and another critical value over here, and this could be like this, okay? And then the question is, okay, well, that's a closed circle, so this one gets an underline. That's an open circle, so this one does not get an underline. Simple as that. Draw a number line for the compound inequality. X is greater than 6. Okay, well, let's just put a little mark near the critical value. This is a special value, 6. Negative 3 is a special value. Let's pay attention to the first piece of information. X is greater than 6. Okay, well, that's an open circle, and it's greater than. So it's like that, okay? X is less than or equal to negative 3. Well, it's less than or equal to, so that's going to be a closed circle, and it's to the left, because that little arrow is pointing to the left. That's how you do that. Evaluate 6 to the 4th power. Well, if we were to evaluate that, that is literally 6 times 6 times 6 times 6. That's 36 times 36. And 36 times 36 is 1296. Okay. Circle the, okay, we don't care about that. Number 3, evaluate that. Okay, so in other words, you can have c and then d squared minus 1, but c is negative 1 and d is negative 6. Now, the reality is according to PEMDAS, we should apply this exponent first. So negative 6 squared, negative 6 times negative 6 is positive 36. So on the next line, I'm going to write negative 1 times positive 36 because that's what it is. And then we have negative 1 times 36, which is negative 36. And then we have negative 36 minus 1, and that gives you negative 37. Okay? Notice how PEMDAS was important. Okay, anytime you have a negative exponent, what that means, all you have to do is take the number and put a 1 on top of it and stick it down below, change the sign of the exponent. That's what you do. You take this 4, shove it down into the denominator, and instead of negative 2 as the exponent, it's going to be positive 2 as the exponent. That's what you do when you have a negative exponent, and then it becomes 1 over 16, and then you are done. How can you simplify the expression? Well, this would be 4. 2 squared is 4. 2 to the 3rd power is 8, and that's going to become 32. Simplify this. The reality is there's an invisible exponent of 1 hovering above that a, and the reality is there's an invisible exponent of 1 hovering above that b. So in reality, you could say it's really a squared times a to the 1st power times b to the 1st power times b to the 3rd power. You could just kind of rearrange the order. And then whenever you have the same base but different exponents, you actually keep the base and you add the exponents. I'll color code these exponents. I'll color code these exponents. The 2 plus 1 becomes a 3. And then we have the b, and the 1 plus 3 up there becomes a 4, and then you're done. A to the third times b to the fourth. That's how you do those. In this one, anytime you have the same base over another base, but the exponents are different, you can keep the base, but subtract the bottom exponent from the top exponent. So that's going to become x to the third. In this case, you can apply that exponent to all of the things, okay, all the factors in there. So in reality, it becomes 3 squared. I'll wrap that in parentheses. It's going to become x squared, and it's going to become something else called y cubed squared. Now, 3 squared is just 9. X squared, you could just say is x squared. But anytime you have a power raised to another power, you can keep the base, but multiply the exponents. So that's going to become y to the 6th. That's the law. That's the rule there, okay? So quick recap of the rules. Anytime you have the same base times another base, you keep the base and add the exponent. Anytime you have a base where it's a power raised to another power, that's a different situation, you keep the base and multiply the exponents. Anytime you have the same base over another base, but the exponents are different, you can keep the base, subtract the bottom exponent from the top exponent, and then you're done. Okay, what is this written in standard form? So that 10 to the negative 4 is basically telling you, take that decimal, move it over to the left 4. If that was a positive 4, you'd be moving it to the right 4, but since it's a negative 4, you're going to be moving it to the left 4. So that becomes a situation where you move it to the left 4, so it's going to be 1, 2, 3, 4. Then you ask yourself, how many containers did I make? Well, there's one here, there's one here, and there's one here. You put little zeros there. And then you realize that, okay, but the new position of the decimal is right there. So it's going to become 0.0007. And if you want, put a little zero in front. Okay, so that's the answer. You take the decimal, move it 4 times to the left, and then fill up the little containers with zeros, which are right here. There's 3 zeros. And if you want to be fancy, put a 0 in front of the decimal. Okay, so that's that. This written in standard scientific notation, well, it's 567.09000. Now, what you want to do is you want this decimal to go here, okay, right between the first number and the second number. So the question is, how many steps would that take? It's going to be 1, 2, 3, 4, 5, 6, 7, 8 steps. So what you do is you just rewrite it as 5.6709, okay, because the rest is just zeros after that. And then you write times 10 to the, how many was that again? 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 10 to the 8th, okay? So anytime this exponent is positive, that means that the number is actually big. This was a negative exponent, which means the number is small, okay? But that's how you do it. You realize, okay, big number. It's not like a decimal number. It's like 567 million. So that's going to be a big number. So that's going to be something with a positive exponent. But then you just, walk it over. It's 8, and then you're good to go. This one right here, I'll rewrite the original. So that 7 up there is telling me how many places I need to move this decimal to the right. So it's going to go to the right 7 places. So if we were to sort of calculate that, it would be 1, 2, 3, 4, 5, 6, 7. And then you fill it up with little zeros. And that is what it's going to be. It's going to be 2701 with 4 zeros. Now, if you want to put commas in there, you could do every 3, right? So that's 27,010,000. Okay. This one. So we're looking at 4.09 times 10 to the negative 5. So that's a negative, so we're going to be moving this decimal to the left, right? We're going to be moving that to the left. So I'm going to rewrite 4.09, but it's going to go to the left 5 places. 1, 2, 3, 4, 5. Put zeros there. And the new home for the decimal is right there. So if we want to get fancy, we can say 0 point, how many zeros? 4 zeros. All right. And then we got that 409 hanging out. You're good. That's how you do that. Finally, this one, 5,063. Or it's not 5,000. It's way more than 1,000. So the decimal is right here, but how many places do I have to move it in order to put it here? Remember, we want it right between the first and second number. That's what we did with this one, right? Didn't we put it right between the first and second number? Well, it's the same situation. Put it right between the first and second number. So let's see. That would be a matter of doing 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 5.063 times 10 to the 9th. Okay, solve the following problems. Okay, anytime the square roots are the same, you could just treat it like almost as though it was 3x plus 8x. You just treat it like terms. That's going to become 11x, or 11 radical 7. For the same reason, this would be 3 radical 3. This would be, imagine it was 5x plus 6x minus 3x. What would you do in that case? Well, the 5x plus the 6x is 11x, and 11x minus 3x is 8x. But it's not x, it's radical 2. So it's going to be 8 radical 2. Same philosophy, though, applies for these as would apply for just if it was x, okay? This is multiplication. This is a little bit trickier. I would multiply the normal numbers first. 7 times 5 is 35. Just put that off to the side, but then you have radical something. Well, the thing is that you could just actually take into account the law that says anytime you have radical 3 and radical something times radical something else, well, it could be the radical of 3 times 2. The radical of the product goes underneath there, and then you're done with that. Similarly, this could be a matter of taking the normal numbers into account. 14 over 7 is really just 2. And that's going to be 2 radical 6 over 2, and that's really 2 radical 3. Okay, so it's almost like the reverse of what we did here. I mean, you multiply the big numbers first, 35. Radical product of 3 times 2, radical 6. Deal with the normal numbers first. 14 divided by 7 is 2. Then it's radical 6 divided by 2, which is just 3. So it's 2 radical 3. This, for the exact same reason, is going to become negative 12 radical 10. And then you're done. Algebraic expressions and word problems. Jim and Brian can shovel the driveway together in 6 hours. If it takes Jim 10 hours working alone, how long will it take Brian working alone? Okay, well, that's interesting. So these are a very specific kind of problem, like that might require you sort of being taught how to handle these specific types of problems. It's kind of difficult to figure it out when reinventing the wheel. But we're going to have a fraction representing Jim. We're going to have a fraction representing Brian, and we're going to have a fraction representing their combined efforts. All right. And it's going to be such that, let's see, Jim takes 10 hours. So what you do is you write 1 over 10. Now you always put a 1 up top, at least for these kinds of problems. And then for Brian, we don't know how much time it would take Brian to work alone, but it would be 1 over whatever that number is. And then over here, it's going to be 1 over their combined time of working together, which is 1/6. All right. It's kind of weird, right? It's a weird setup, but just know you're going to want ones across the top. This is how much time it takes one guy to do it by himself. This is how much time it takes the other guy to do it by himself. And this is how much time it takes for both of them, combined efforts, to do it by themselves. And basically, you just have to solve for x at this point. Now, the way to solve for x is I would clear the fractions. Now, the least common multiple of all of these numbers is 60x, okay? 60x. Now, how do I know that? Well, 60x is divisible by 10, right? Because 6x times 10 gives me 60x. 60x is divisible by x because 60 times x gives me 60x. And 60x is divisible by 6 because 10x gives me 60x. 10x times 6 gives me 60x, okay? So 60x is the least common multiple. So what you're going to want to do is you're going to want to multiply everything by 60x. Multiply everything by 60x. Okay, we're going to hover it above, hover it above, hover it above, like that. Now, in doing so, this 60 cancels out with a 10. That becomes a 6, that becomes a 1. Over here, this 60x does cancel with the x, but it's only the x's that cancel. Over here, this 60 becomes a 10, and that becomes a 1. That becomes a 1 down here too. And then only, we still have the 10x left over here. So on the next line, we could write, well, let's see what's left here. All the denominators are gone. By the way, that's the whole reason I came up with that least common multiple of the denominators. I chose to multiply everything by that least common multiple because it knocks out the denominators. So we're going to have 6 plus, let's see, what's left over here. We have 60 left over here, plus 60. This should be 6x. I forgot to write the x. There was still an x right there. I should have written that x. And that all equals, let's see, what's left over here. We have 10x times 1, so that's going to become 10x. Now, at that point, let's get rid of this. At that point, we could choose to subtract 6x from both sides. We're going to have 60 equals 4x, and then divide both sides by 4. You're going to have x equals 15. So it would take Brian 15 hours if he was working alone. Okay, a sixth grade class bought 2 different types of candy to sell at a school fundraiser. They purchased 50 pounds of candy at $2.25 per pound, X pounds at $1.90 per pound. What's the total number of pounds they bought if the total money amount of money spent was 169.5? So we know that the total pounds is equal to 50 pounds plus X pounds. I mean, that's ultimately what it is. 50 pounds plus X pounds. That's the total number of pounds, right? So our goal is to figure out what X is, and once we find X, we get to add it to 50, and then we have our answer. Okay, so we have to figure out what X is, though. How many pounds did they sell at 190 per pound? Well, you can use the information they gave you. They purchased 50 pounds, so that's going to be 50 pounds times 190 per pound, or 225 per pound, pardon me. And that's going to be plus X pounds times 190 per pound. And apparently that all cost 169.5. Okay, that all equaled, we could say, 169.5. So 50 times 225 is 112.5. Plus, and I'll call this 1.9x. It's just a little nicer looking. Let's subtract 112.5 from both sides, and that would give us 1.9x equals 57. At that point, we can divide both sides by 1.9, and that would result in x equals 30. So that's a nice number. So remember, we're not done yet. We did find x, so that's the amount of pounds they purchased at 190 per pound. Remember, the end goal is to take 50 and then add it to x, right? So 50 plus 30 is 80. So the total weight is 80 pounds. Okay. Circle the rays. Well, rays look like this. So there's a ray, and there's a ray. Draw a square around the lines. Here's a line, here's a line, here's a line, here's a line, because lines look like this with double arrows. Identify all the names that describe this quadrilateral. Well, first of all, you have a family of quadrilaterals called parallelograms, where that side is parallel to that side is parallel to that side, these two opposite sides are parallel to each other, these two opposite sides are parallel to each other. Now, parallel means they're like train tracks. They go on forever without ever crossing, okay? Now, that's called a parallelogram, which is a crazy word, but there's two very special kinds of parallelograms. One is called a rhombus, um, where it's a parallelogram, but it happens to have like equal sides. And there's another thing called a rectangle, where that's a parallelogram as well, but it's a special kind of parallelogram. That's a parallelogram where the sides aren't necessarily equal, but it is the case that there's 90 degrees at the corners. Now, 90 degrees is typically denoted with this little box here, okay? And then there's this super special kind of parallelogram called a square. And a square features all of the above information. There's 90 degrees at the corners. There's also the side lengths are all equal across the board, just like a rhombus, you know what I mean? So a square features a lot of properties. Okay, that's a rectangle. That's a parallelogram. Okay, and that's a square. Now, why did I draw it like this? Well, these are arrows, really. Okay, this is like a flow chart. Because the truth is that um, a rhombus is a type of parallelogram. A rectangle is a type of parallelogram. A square, you could say, is a kind of rhombus. A square is a special kind of rhombus. You could also say a square is a special kind of rectangle. It happens to be the kind of rectangle that has four equal sides. Okay? And because a rhombus is a kind of parallelogram, because a rectangle is a kind of parallelogram, and because a square is a kind of rhombus, and because a square is a kind of rectangle, well, then it stands to reason that a square is also a kind of parallelogram, right? Now, all squares are therefore parallelograms. All rhombuses are therefore parallelograms. All rectangles are therefore parallelograms. But it's not necessarily true that all parallelograms are rhombuses. There are millions of parallelograms that are not rhombuses, right? This is a parallelogram that's not a rhombus. The side lengths are not equal, right? Not all parallelograms are rectangles. Sometimes you're going to have these acute angles here. You're going to have these obtuse angles here, right? So that's the sort of meaning of the flowchart. So identify all the names that describe this quadrilateral. Well, it's definitely a square, but a square is a kind of rhombus, so we should say rhombus. And a square is also a kind of rectangle, so we should call it a rectangle. And, you know, a square is also a kind of parallelogram, so we should call it a parallelogram. Okay, so that's that. Okay, this problem features a typo. This should say 7x minus 4. All right, so we're going to get rid of that. And this should say 3x plus 18. All right, so there's a typo here. Now, they want the perimeter. Now, we know that the perimeter is a matter of adding all the side lengths, okay? They should have also mentioned that this is a rectangle, so these are 90 degrees. And if it's a rectangle, it's the case that this side is equal to this side. And if it's a rectangle, it's the case that this side has to be equal to that side. So if that's true, then this has to be 27.3. Okay, so then the question is, okay, well, I want to add all this, but I don't know what x is, right? I don't know what x is. So if I don't know what x is, how am I supposed to know the perimeter? Well, you take advantage of the fact that you know that since it's a rectangle, this red side equals this red side. So therefore, 7x minus 4 has to equal 3x plus 18. And you can literally solve for x. Subtracting 3x from both sides would be 4x minus 4, and that equals 18. Adding 4 to both sides would be 4x equals 22. Dividing both sides by 4 gives me 5.5. Okay, now if x is 5.5, then this is 3 times 5.5 plus 18. And that's going to turn out to be 34.5. Now, if that's 34.5, and that's, what this red side equals. Well, I don't need to worry about x here. This whole thing is just 34.5 up here as well, right? Because the red side length is equal to this red side length, and this red side length is 34.5, so that one also has to be 34.5. So this is going to be the perimeter is going to be a matter of adding the two red side lengths plus the two other side lengths, 27.3, and then that's going to give you your perimeter, and that equals 123.6. So that's how you do that one. Find the area. So the area of any circle is pi times the radius squared. Now the radius is 1/2 of this total length. This total length that goes across is called the diameter. The radius is 1/2 of that. So we're looking at a 5, right? The radius is 5. So the area is pi times 5 squared. Now 5 squared is 25. So this is going to become pi times 25. Now, it is the case that pi is approximately 3.14, so you could always multiply 3.14 times 25, but also it is customary to leave the answer as 25 pi as well. Okay, so find the area here. Well, it'd be nice to know what these red side lengths are, because the reality is when it comes to the area of a rectangle, that's just length times width. We could call this the length, and we could call this the width. And we need to find out what the length is and what the width is and multiply them together, and then we're done. Now we have the length. The length is 12. But the question is, what's the width, right? What is the red part? What is this red side length? Okay, that's the width. Okay, what is the red part? Well, you could find out what it is by setting x minus 5 equal to 112 minus 8x, okay? So that's x minus 5 equals 112 minus 8x. Adding 8x to both sides gives me 9x minus 5 equals 112. Adding 5 to both sides gives me 117. Dividing both sides by 9 gives me 13. So if x is 13, well, x minus 5 is 13 minus 5, which is 8. Okay? Now, that means that this whole thing is 8 as well, but I could ignore this expression. The whole thing is 8. So therefore, we know that the area is length times width, so that's going to be 12 times 8. And 12 times 8 is 96 meters squared, you could say. All right, area is units squared. Okay, so this one is a weird one, right? This is a weird one. So basically, you need to acknowledge the fact that the total area of this is going to be the rectangle part plus this semicircle part, right? Now, this semicircle part right here is just half of a circle. It's half of a circle. Whereas this rectangle part is clearly 14 times 17, 14 by 17. This is a half of a circle. If it was a full circle, the diameter would certainly be 14, which means that the radius is 7, okay? So imagine this was a full circle. Imagine this was a full circle. Well, what would it be? It would be pi r squared, right? And the radius is 7, so that would be pi times 7 squared. So that's going to be 49 times pi. Now, they actually told us to use 3.14 for pi. So what we're going to do is we're going to go ahead and multiply 49 times 3.14, and that's going to give us 153.86. Okay, 153.86. Now, that's the area of the full circle, but we're looking at half of that, right? So what's 153.86 divided by 2? Well, that would end up being 76.93, okay? 76.93. So this is 76.93. And then the question is, well, what's the area of this? Well, it's 14 by 17. So that's going to be 14 times 17. And 14 times 17 is 238. So then all you have to do is just add these together. 238 plus 76.93. And that's going to give you 314.93. Okay, so that's how you do that one. You recognize it's a rectangle part, it's a semicircle part. Find the area of the rectangle is 238. Semicircle is going to be what it would be if it was a full circle, only cut in half. So the full circle is this. Divide it by 2, you get 76.93, and then you're good to go. Okay, which letters have line symmetry? Well, line symmetry is when you fold it and one half matches the other half. So Z, if you were to fold that down the middle, it would not land on top of itself. S would not land on top of itself. H would, all right, because if you were to divide, or if you were to fold it across this part would just flip over and it would become like that. You know what I mean? So you kind of use your three-dimensional reasoning. Imagine this being folded and it would just land perfectly on top of itself, whereas Z would not. Z would, it would be all weird looking if you were to do Z. So what about O? Does O have line symmetry? Well, yeah, if you were to fold that across, that would land on top of itself. So O is a letter that happens to have line symmetry. E does have line symmetry if you were to fold it across this half. If you were to fold it like that, it would turn into something that looks like this. But really, regardless of what it would look like, the fact is it would land on top of itself. That's the important part. N does not have line symmetry. C has line symmetry if you were to fold it across this one for the same reason that E would land on top of itself. Well, C would land on top of itself. Let me make it look a little bit more like it would do that, right? So C would land on top of itself. Okay, so rotational symmetry is when you take a figure. Let's take Z. Let's take Z. And basically you take that figure and you rotate it around its center point. So we have a Z. The center point would be right around here. And essentially what you're doing is you're asking yourself, if I was to rotate this around its center point, 360 degrees, well, that would be a matter of like that, right? Okay, let's say that this blue part was the bottom, okay? And we took it, we rotated around 360 degrees, and then we would end up here again, wouldn't we? Right? So rotational symmetry concerns itself with whether or not, during that path, was there any moment where it landed on top of itself again, or where it became a Z again, during that whole trajectory? Well, let's see. When we rotate it 90 degrees, it doesn't look like a Z. But when we rotate it 180 degrees, boom, look, it's a freaking Z. It's a Z. So therefore, this thing does have rotational symmetry. Okay, so if it lands on itself along the way, you know, during that trek to a 300, during that trek of a 360-degree rotation, well, then we say that it has rotational symmetry. Okay, now it lands on itself twice during that trajectory. So therefore, I shouldn't really call it a trajectory. During that rotation, that 360-degree rotation, it lands on itself twice, once at 180 degrees and once at 360 degrees. And when I say it lands on itself, what I mean is it becomes a Z twice. It becomes a Z at 180 and it becomes a Z at 360. So this letter Z has a rotational symmetry of order 2. Okay, that's why they say order 2. So let's look at S. We got this S here. Let's imagine that this is the bottom part, and let's just see what happens. Well, when I rotate it 90 degrees, it becomes that. That's not an S. When I rotate it you know, 360 degrees, it becomes that. Boom, that is an S, right? All right, that's 180 degrees, I should say. When I rotate it 270, it's not an S. And when I rotate it 360, it's like that. That's an S. So it did become an S during that 360 rotation. It became an S at 180. So therefore, S has rotational symmetry as well. Okay. Let's look at H. Okay. Let's say we're looking at H, and let's say this is the sort of, you know, just a little placeholder there. So what happens when I turn H 90 degrees? Well, that's not an H. What happens when I go 180 degrees with it? Well, that's an H. Boom, boom, ding, 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 ding. So it became an H at 180 degrees. When I go 270 degrees, it's not an H. And when I go 360 degrees, it's an H again. So it did become an H at 180 degrees. So H has rotational symmetry. When you look at O, does O have rotational symmetry? Well, yeah, it does actually. It's got a lot of rotational symmetry because think about it. You go 90 degrees, well, it's an O. You go 180 degrees, it's an O. You go 270 degrees, it's an O. And you go 360 degrees, and that's an O again. Now, this has rotational symmetry of order infinity because there's not a single moment, there's not a single angle turn, there's not a single angle of rotation where it's not an O because it's an O the entire time, okay? So that is a letter that has rotational symmetry. What about E? Let's look at this E. Well, this will be the sort of bottom half of it. So if we turn it 90 degrees clockwise, it's not an E. If we turn it 180 degrees, it's actually not an E. 270, not an E, and only 360 is it an E. So this does not have rotational symmetry because it does not turn into an E during that 360 degree rotation except for the very end. Let's look at this N now. So we have N. We'll call this, we'll say the red part is on the left, okay? So what happens when we turn it 90 degrees? Well, is that an N? No. What happens when we turn it 180? Is that an N? Yes. 270, is that an N? No. 360, is that an N? Yes, it's an N again. Therefore, it did hit N at 180 degrees. So we're going to say N has rotational symmetry. So we're going to look at C now. Bottom half of the C is right here. So when we rotate C 90 degrees, that's not a C. When we rotate it 180, that's not a C either. When we rotate this 270, it's not a C. And when we rotate it 360, it becomes a C again. But of course, it should become a C again at 360. So C does not have rotational symmetry. So these are the letters that do indeed have rotational symmetry. Okay, which of the terms describes this triangle? Well, you can classify triangles by their angles and side lengths. Okay, now when it comes to angles, okay, we're going to look at each of these. When it comes to angles, if all the angles inside the triangle are less than 90 degrees, then that's acute, okay? If you have one angle inside a triangle that's larger than 90, we call that an obtuse triangle. And if you have one angle that's perfectly 90 degrees, that's going to be a right triangle, okay? Similarly, if you have if you have a triangle that has two equal side lengths, we call that isosceles, okay? If you have a triangle that has no equal side lengths, we call that scalene. And if you have a triangle that has all equal side lengths, we call that equilateral. And we could also say there's really this other thing where all the angles are equal to each other. We call that equiangular. All right, equiangular. Equiangulars also always happen to be equilaterals. Okay, that's just something to know. So when it comes to the angle aspect of this triangle, we definitely have this obtuse angle here because that's larger than 90 degrees, so it's definitely obtuse. And we also know that it has two side lengths that are equal due to these tick marks. So that's called an obtuse isosceles. Hopefully my spelling is good. Select the right name for the following triangle. So all sides have different measurements. So apparently already we know it's scalene. So far we are looking at this one and that one. There's a right angle that makes it a right scalene. Okay, so that's how that works. Name the radius shown. Name each radius shown in the circle. Well, we have this red radius shown in the circle. We have this blue one. We have a yellow one, and we have a brown one. The red one we call LJ. Okay, segment LJ. The blue one we could call MJ. The yellow one we could call KJ. And the brown one we could call NJ. That's all there is to that. Okay, what are the diameters shown in the circle? Well, we have the large purple diameter, and we have the big red diameter. And the purple diameter is a segment called MN, and the red diameter is a segment called LK. Now, the order does not matter. I could have called this NM, and I could have called this KL. Okay, so that's that. Let's see, we'll erase this. If length of MJ is 15, okay, I'll write that right here, 15. What is the circumference of the circle? Well, the circumference of any circle is 2 pi r. Okay, now circumference is basically the perimeter of the circle, the distance all the way around. So the circumference is 2 pi r. Now that's going to be 2 times pi, and r we already know is 15. They literally just told us. They said MJ is 15. Well, that's a radius. That's a radius. MJ is a radius. So the circumference of this circle is going to be 2 times pi times 15. You could also say that's 2 times 15 times pi, also known as 30 pi. So that's that one. Okay, volume of solids. Let's see. A cylinder has a volume of 45, blah, 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 which is volume of the radius, blah, blah. Okay, so the volume of a cylinder, first of all, a cylinder looks like this. All right, looks like that. And we call that the height. We could say that's the radius, right? And the volume of a cylinder is pi r squared times the height. So that's pi times the radius squared times the height. Okay, so the question is, when I do radius squared times height times pi with these answer choices, which one gives me 45 pi? Well, if this radius was squared, it would be 81, and 81 pi times 5 is way bigger than 45 pi. If this radius was squared, that would be 9, and then it would be 9 times 15 pi, and that would be larger than 45 pi. If this was squared, that would be 25 times 3, which is 75 pi. So the only one that works is D, okay? If you were to square this radius, that would be 9, and then 9 times 5 is 45, times pi is 45 pi. So that works. All right, Terry fills with water 2/3 of a glass that is 15 centimeters tall. If the radius of the glass, what volume of water is in Terry's glass? Okay, so what's the volume of the whole glass? The volume of the whole glass would be pi times radius squared. That's going to be 2 squared times the height. Now the height is 15, right? So that would be pi times 4 times 15. And that would be 60 times pi, okay? Now that would be the volume of a full glass, but we want 2/3 of that. So the question is, what's 2/3 of 60 pi? Well, that would just be That would just be a matter of remembering that of really means multiplication. So you could just do 2/3 times 60 pi. Well, I know the pi could be confusing, but the reality is there's just a 1 under there. And it's really just three numbers being multiplied together. You have 2/3 times 60 over 1 times something else called pi, which we're just going to leave off to the side. Focusing only on the 2/3 times 60, this becomes a 1, that becomes a 20. So we're going to end up with 40 pi. Okay, 40 pi. So that's the answer to that one. All right. We found the volume of the entire glass first, and then we took 2/3 of that. Okay. Looking at problem number 3. Height of cylinder B is 3 times the height of cylinder A, and the radius of cylinder B is 1/3 the radius of cylinder A. What's true about the volume of both cylinders? Well, that's definitely confusing, huh? That's a little confusing. All right, so we're going to work that out. Let's erase all this. So the height of B equals 3 times the height of A. The radius of B is 1/3 the radius of A. Now, we could also say that the volume of cylinder A is pi times the radius of A times the height of A. Now, we could also say that the volume of B is pi times the radius of B times the height of B, of course. But we know that anytime we see the height of B, we could just replace it with 3 times the height of A. Anytime we see the radius of B, we could replace that with 1/3 times the radius of A. So we're going to actually kind of tweak this one a little bit. The volume of cylinder B, therefore, equals pi. But instead of the radius of B, I'm going to write 1/3 radius of A. All right, because the radius of B is equal to 1/3 radius of A. So instead of writing this, thing, I'm going to replace it. Similarly, with this purple part, instead of writing the height of B, well, we know that the height of cylinder B is equal to 3 times the height of A, so I'm just going to write 3 times the height of A. All right. Oh, my bad. This should be squared. Squared. I forgot that part. So looking at this, we have pi times, well, what is 1/3 squared? That's 1/3 times 1/3. That's going to be 1/9. Radius A squared, because what is radius A squared? Well, that's just radius A squared. And then we have 3 times the height of A over here. So we have 3 times the height of A. Now this 3 secretly has a 1 underneath it, and we have a 1/9 here, we have a 3 over 1 here. The reality is that we can cancel that, becomes a 3, we can cancel that, becomes a 1. And then if we were to simplify that one further, it would become, looks like it would become 1/3 pi radius of A squared, times the height of A. Now, doesn't this part match this guy? Okay, I'll wrap it in yellow. Doesn't this yellow box equal this yellow box? So what we've realized through our calculations is that the volume of cylinder B is 1/3 the volume of cylinder A, because the volume of cylinder A is the yellow box, so the volume of cylinder B is 1/3 of the yellow box. So that's what we know about the volume of the two cylinders. That's probably the hardest problem in the entire video, I have to tell you. Let's see. The radius of a cylinder is 2x, and the height of a cylinder is 8x plus 2. What is the volume of the cylinder? Okay, so the volume is equal to pi r squared times height, and that's equal to pi times something squared times something. And the radius, apparently, is 2x, according to the problem. And the height is apparently 8x plus 2. So then if we were to simplify that a little bit more, it'd be pi times 4x squared times 8x plus 2. Cool. So great, we could call this 4 pi x squared off to the side times 8x plus 2. And we could kind of treat this as one big term here that we could then really distribute to both of these. So that would become 32 pi, not x squared, but x cubed, because this x squared times that x is equal to x cubed, plus 8 pi x squared. So that's really complicated and annoying as well, but that's the answer to that one. Okay, let's clear away some of this stuff. Problem number 5. The height of a cylinder is 4 times the radius of the cylinder. If the volume of the cylinder is that, what is the radius of the cylinder? Okay, so the height of the cylinder equals 4r, right? We also know the volume of any cylinder is pi r squared times h. Now the volume of this thing apparently is 256 pi. Okay, and we know that that equals pi times something squared times something. Well, apparently that is radius squared times the height squared, but we already know that the height is equal to 4 times r, so we're going to actually just put 4r in there, okay? So instead of writing this h, I'm going to replace the h with this 4r, because h equals 4r. That's what we're doing. At this point, we can divide both sides by pi, and that cancels the pi. Next thing we know, we have 256 equals 4r cubed, okay? Because the r squared times that r is just r cubed. At that point, we can divide both sides by 4. We're going to have r cubed is equal to 256 divided by 4, which is 64. And the cube root of 64 is 4, because 4 times 4 times 4 gives me 64. So that's the radius. I think that's what they asked for. So we're good. Problem number 6. The length of a rectangular solid. Length of a rectangular solid is twice the sum. Okay, so we're going to say L equals 2 times the sum of the width and the height. Okay. If the width is equal to the height and the volume of the solid is 108, what's the length of the solid? Okay, so we also know that the width is equal to the height. The width is equal to the height and the volume is 108. What's the length? Okay, so when they say rectangular solid, first of all, they're talking about this. Something like that. And basically, that's the height, and we can say that's the length and that's the width. All right, and the volume, by the way, is going to be length times width times height. So they gave us all this information, though, right away. They're like, the length happens to be 2 times the sum of the width and the height. It's also the case that the width is equal to the height, right? It's also the case that the volume is 108. So let's start to piece this together. The volume is 108, and that's going to be a matter of the length, times the width times the height, right? Well, the width equals the height, so these two things are the same. And ultimately, we want to find the length of the solid. So wouldn't it be nice if we could just have nothing but L's over here, right, for length? then we could just solve for L and we'd have our answer, right? We'd just solve for L and then we'd have our answer. But the problem is we have a W and we have an H. So there's got to be a way of getting rid of it. Well, one thing I'll say right now is that W is just W, right? And apparently W equals H. So I can replace this H with a W. Maybe that'll be helpful. And then we still have our length here, right? We still have our length here. So let's kind of look at this one though. Length equals 2 times width plus height, but isn't that 2 times, width plus width? Because the reality is W equals H. So when we say W plus H, can't we just replace this H with a W? So we have 2 times width plus width. So that would be length equals 2 times 2W. And that's equal to 4W. Okay, so the length equals 4W. Okay, so ultimately we want to replace these W's with something that says L though, right? So we actually have an opportunity here to divide both sides by 4, and then we'll end up with W equals L over 4. So what we've just learned is that anytime we see W, because of this original equation and because of these two equations, anytime we see W, you can just replace it with an L over 4. So that's exactly what we're going to do here. We're going to say 108 equals L times L over 4 times another L over 4. All right? So in other words, these yellow guys got replaced with these yellow guys because of this. So 108 equals, the reality is there's secretly a little 1 underneath there. So across the top, we have L times L times L, which is L cubed. And down below, we have 1 times 4, which is 16. We could then multiply both sides by 16. That would cancel those. And then the next thing you know, we would have L cubed equals 1728. And then if you were to take the cube root of that, that would be 12. All right, because the reality is that 12 times 12 times 12 gives you 1728. Okay, so that's the length, and that's what they asked for. That's how you do that one. Okay, the area of one face of a cube is 9x square units. What is the volume of the cube? Well, let's see. The area here is 9x, and that's a result of side times side. So side squared equals 9x, okay? So one of those sides is equal to the square root of that. So that would be 3 times the square root of x, all right? Now, how do I know that? Because, if I was to take the square root of both sides, well, the square root of s squared is just s, and the square root of 9 is 3, and the square root of x is square root of x. Okay, so that is the side length in terms of x. So in a way, we could just rewrite this cube as having that side length, where this side is 3 radical x, this side is 3 radical x, and this side is 3 radical x as well. Now, the dimensions or the volume of a cube is side cubed, okay? So the volume of this cube is going to be 3 radical x cubed, all right? So that's what they're looking for. Ultimately, they want the answer in terms of x. Now, this gets applied to both of these. So you're going to have your 3 cubed, and then you're going to have the weird situation where it's the square root of x cubed. Now, we'll investigate this. 3 cubed is just 27. 3 times 3 times 3 is 27. But then we have this kind of weird situation here. So what we could do is we can investigate this sort of blue part here. All right, we're gonna investigate that off to the side. Isn't it true that radical x cubed, I mean, that's just radical x times another radical x times another radical x. That's all it is. And isn't this just, you know, radical x squared? And then we have this extra radical x off to the side. Okay? Now, the reality is an exponent of 2 cancels the square root symbol. So this exponent of 2 cancels that square root symbol. And the next thing you know, we are left with x radical x. Okay? Where you could say the yellow brackets just became that. Okay? So in reality, we could say this is 27 times x times radical x. And that's what the volume equals. And ultimately, that's what they were asking for. They said the area of one face is 9x. We know that the area of a square is side squared, so side squared is 9x. So the side length has to be 3 radical x. So we could redraw the diagram, 3 radical x by 3 radical x by 3 radical x. Then we remember that the volume is side cubed, so it's going to be that, 3 radical x cubed, and then we just simplified that. We applied the exponent to the 3, it became a 27. We applied the exponent of 3 to the radical x, and it became x radical x, so that's the volume. Okay, looking at problem number 8. The volume of a rectangular solid A is equal to the volume of rectangular solid B. The length of solid A. Okay, so the volume of rectangular solid, just in general, is length times width times height. So the volume of A is equal to the volume of B. And apparently also it's the case that the length of solid A, so the length of A is equal to 3 times the length of B. Okay, fine. And the height of A is equal to 2 times the height of B. And write a set that's comparing the width of solid B to the width of solid A. Well, that I don't know necessarily. So let's just piece it together here. We know that the volume of solid A is going to be the length of A times the width of A times the height of A. The volume of B is going to be the length of B times the width of B times the height of B. And we know that these volumes are equal. Now, the length of volume A is also 3 times the length of volume B, right? So length of B, I should say. So this red guy became that red guy. This blue one, the width of A, we don't know yet what's going on with that, so we're just going to leave that. Then we have we'll say purple part, which is the height of A. Well, apparently that's 2 times the height of B. Okay, according to this stuff, right? I'll keep it color-coded. So that's all true. And then we can set that equal to this part on the right. Now, it is the case that we can divide everything by the length of B. If we were to divide everything by the length of B, then those would cancel. We could also divide everything, both sides of the equation by the height of B, so that would get rid of the HB. And then what would we be left with at that point? Well, on the left, we would have 3 times the width of A times 2, which simplifies which simplifies and turns into 6 times the width of A. And then that's going to equal the width of B. And then we are basically done. So apparently the width of B is equal to 6 times the width of A. And that's ultimately what they're getting at. They're like, write a sentence comparing the width of solid B to the width of solid A. Well, we just discovered through this process that the width of B is equal to the width of 6 times the width of solid A. So that's actually what you could write. Okay. The width of solid B is equal to 6 times the width of solid A. So that is how you do that one. Okay, let's see. Get rid of this. Problem number 9. The length of a rectangular solid is 6 units and the height of the solid is 12 units. The volume of the solid is 36. Okay, so we know that the volume of a rectangular solid is length times width times height. The volume of this solid is 36, and that's going to be something times something times something. The length is apparently 6. They give that to you. The height is apparently 12, and they want to know the width. Well, this is a relatively easy one, actually, compared to the ones that we've been doing. So 36 equals 6 times 12 is 60 plus 12, which is 72. So that we have the width, and then if you divide both sides by 72, you would get 36 over 72, which is just 1/2. Okay, a rectangular solid measures 4 units by 5 units by 6 units. What's the surface area of the solid? So surface area has to do with how much area is sort of covering the entire object. Now, there is a decent formula that you can use where the surface area equals 2 times the length times width plus the width times the height plus the length times the height. So even though that kind of seems maybe a little confusing in the beginning, it is something you're going to get the hang of after some practice of realizing, okay, well, let's call that the height, we'll call that the length, we'll call that the width. Okay. And just know that these pairs are just, one dimension matched with the other. Make sure that, every potential pair of these three gets represented. Length times width, width times height, length times height. It's really as simple as that. Once you get familiar with that formula, then it becomes relatively easy. So the surface area in this case would be 2 times, we can say 4 times 5 plus 5 times 6 plus 4 times 6. And 4 times 5 is 20 plus 30 plus 24. And we are looking at 2 times 74. And that would be 148. And that's all there is to that one. All right, looking at problem number 2. Problem number 2. Danielle's cube has a volume of blah, blah, blah. What's the surface area? Okay, well, it's a cube. So that means that all the side lengths are the same. Okay. And we know that the surface area is going to be 2 times length times width, width times height, and length times height. But really, that's going to be side times side, plus another side times side, plus side times side, right? Because the length and the width and the height are all equal to S. They're all equal to the side, side lengths. So I think you would agree that if we could just find the S, then we would be on our way to the answer. Well, the volume of a cube is side cubed, right? And they actually give us the volume. It's 512, and apparently that's side cubed, or side cubed is apparently 512. So the cube root of 512 happens to be 8. So therefore, the side length of this particular cube is 8. So all you have to do to find the surface area now is to say 2 times 8 times 8 plus another 8 times 8 plus 8 times 8. And once you do all that, it's going to be 64 plus 64 plus 64 times 2, and that's going to be 384. Okay, so that's that one. problem number 3. The surface area of a rectangular solid is 192. If the height of the solid is 4 units and the length is 12, what's the width? Well, the surface area is 2 times the length times width plus the width times height plus the length times height. And that would be, and we know that the L equals, let's see, the length is 12. We know the height is 4. And then they're asking what's the width. Okay, so you just fill in the numbers. You know it's going to be 12 times W plus W times the height, which they gave us is 4, plus length times height, which is going to be 12 times 4. And that would be 2 times 12W plus 4W. I'll just kind of rewrite that. 4W plus 48. And then we have 2 times, and if you combine like terms, that would be 16W plus 48. And that is distributing the 2 would be 32W plus 96. And they actually gave us the surface area, right? It's 192. So in reality, it's 192. I should have written that each time. So it's 192 across the board. Subtracting 96 from both sides would give us 32W equals 96. Dividing both sides by 32 would be 3. So the width is 3. Okay, problem number 4. The volume of a cube is x cubed units, and the surface area of the cube is x cubed square units. What is the value of x? Well, the volume of the cube, of any cube, is side cubed. Now they're telling us that it's x cubed, so therefore in this particular cube, we know that the volume of this cube is x times x times x, the side length, I should say, of the cube is x all the way around. So the length is x, the width is x, and the height is x. Now we also know that the surface area is 2 times length times width times height times length times height. And that would be, therefore, x times x plus x times x plus x times x. So that would be 2 times, really, 3x squared if you were to calculate that. Now, in case that's not clear as to why I kind of jumped to that this is x squared plus x squared plus x squared. So there's 3 of those x squareds. So therefore, we're looking at 3 times x squared inside here, and it's going to be 2 times that. Now, that turns into 6x squared, okay? So apparently, apparently this surface area is equal to x cubed, okay? So the question is, what's the value of x? Well, we could actually divide both sides by x cubed, or x squared rather, and that would cancel this, and then x cubed divided by x squared is just x. Okay, so x equals 6. Now, in case that's not clear, let's analyze this x cubed divided by x squared. So the reality of x cubed is it's 3 x's being multiplied together. The reality of x squared is it's 2 x's being multiplied together. And the reality is that these would cancel, and it would just leave us with this x here, okay? We could also use one of the previously mentioned exponent rules, where anytime the bases match, you keep the base and you subtract the bottom exponent from the top exponent. So that would be x raised to the 3 minus 2, which is x raised to the first power, which is just x. Okay, so this becomes x equals 6. All right, so that's that one. Looking at this, the width of a rectangular solid is twice the height of the solid. So I'm just going to write that. Width equals 2 times the height. And the height of the solid is twice the length of the solid. So apparently h equals 2L. if x is the length of the solid, what is the surface area of the solid in terms of x? So x is the length of the solid, so we could therefore say, okay, well, h equals 2x, right? I mean, we could say that. We could also say that width equals 2 times h, which is really 2x. So we could also say, therefore, that width equals 4x. So these are sort of some nice updated pieces of information. And they also told us, oh, x is the length, so let's just write that as well. The length equals x. So that's another piece of information that we could definitely use. So we want the surface area of the solid in terms of x. Well, the surface area of anything, any rectangular solid like this, is 2 times length times width, plus width times height, plus length times height. But we're going to want to replace these variables with something that features x. So therefore, we're really looking at 2 times, instead of length, we're going to write x. Instead of width, we're going to write 4x plus 4x. Instead of height, we're going to write 2x because that's right here. And then length times height over here, it's going to be, instead of length, I'm going to write x. Instead of height, I'm going to write 2x. Okay. And then as a result, we then have 2 times 4x squared would be the first thing. That would be this one. This would be 8x squared plus 8x squared. This one would be 2x squared. And at that point, we're looking at 2 times, let's see, like terms. We have 4x squared plus 8x squared, that's 12x squared, plus another 2x squared, that's 14x squared. Okay, and that equals 28x squared, and then we are done with that one. Okay, so which points are located at the coordinates of the following chart? So let's see, -3, 7, that's to the left 3 and up 7, so that's definitely E. Just put that here actually, right? So that's definitely E. 7, 3 is to the right 7, up 3, so that's definitely A. -3, -7, that's to the left 3, down 7, C. -7, up 3 is D. And then finally, to the right 3, up 7 is B. Okay, the slope of a line. The endpoints of a line segment are blah, blah, blah. What's the slope? Okay, well, the slope formula is useful for these. So the slope formula is that the slope is M. We call it M. And that's always going to be y2 minus y1 all over x2 minus x1. And that's, you know, when one of your points is called x1, y1, and another point is called x2, y2. So looking at problem number 1, we could say this is x1, y1, and this is x2, y2. So if we were to use the slope formula, it would be something minus something over something minus something. Well, it would be y2, which is 4, minus y1, which is 6, all over x2, which is 7, minus x1, which is -3. You have to be careful with the negatives. So we're going to have -2, and then 7 minus -3 is really 7 plus 3, which is 10, and that's going to become -1/5. Okay, so that is what you're going to do with those. Now looking at problem number 2 now. The endpoints are that, so we could call this x1, y1, x2, y2. So we are now looking at the slope is something minus something all over something minus something. And in this case, y2 is -5, y1 is -5, x2 is -5, and x1 is 5. So at that point, -5 minus -5 is really negative 5. Negative 5 minus negative 5 is really negative 5 plus 5, which is really 0. So we're going to have 0 up top. Down below, we have negative 5 minus 5. That's negative 10. And that becomes just a 0. Anytime you have 0 in a numerator, it doesn't matter what's down here. As long as this isn't also 0, the whole thing becomes 0. Okay, so that's that. So let's see. Looking at problem number 3 now. So what is the slope of the line segment with endpoints? Okay, well, more of the same. X1, Y1, X2, Y2. So the slope would be something minus something all over something minus something. And we are now looking at 10 minus 2. And then we are looking at 1 minus negative 1. So 10 minus 2 is 8. 1 minus negative 1 down below is really 1 plus 1. Let me just make sure I'm doing the right thing here. Yeah, so that's going to be 2. And that becomes 4. Okay, so the slope is 4. Pretty simple, right? So that's that. Looking at problem number 4. What is the midpoint of the line segment whose endpoints? Okay, so that's the midpoint formula, which is a different formula. The midpoint formula says that this is the case. Okay, this is how you find the midpoint between 2 points. So that's also when you have x1, y1, and x2, y2. So when we go about that, we would just go through the motions. It would be something plus something, something plus something. And what are those somethings? Well, x1 and y1. So we have x1, y1, x2, y2. So we have 0 plus negative 8. And over here, we would have y1 plus y2. So that'd be negative 8 plus 0. Okay. So that would become negative 8 over 2, comma, negative 8 plus 0. That's negative 8 over 2 again. And that's going to be negative 4, comma, negative 4. Okay, so that's the midpoint formula. Okay, looking at this one. Okay, so 5 and 6 are the same. So just go through the motions with that. Same deal. Okay, looking at problem number 7 through 9, though. 7 through 9 features the distance formula because they're asking for the distance between 2 points now. So the midpoint formula is here. Okay, so this is, I'll just say, so this is slope. This is midpoint formula, midpoint. That's x1 plus x2 all over 2, y1 plus y2 all over 2. And then you have the distance formula, okay? So that's this. That's this one. That's going to be x2 minus x1, y2 minus y1, and that is the distance formula. So how do you use that? Well, it's just plug and play, just like the previous problem. So let's call this x1, y1. We'll call this x2, y2. And therefore, in the case of this one, it would be, the structure. I like to draw the structure first. I'm kind of big on parentheses. It's going to be something minus something, something minus something. And then it's x2 minus x1. Well, that would be 2 minus negative 6. And then we have y2 minus y1, so that's going to be 17 minus 2. And we are therefore looking at, over here it's 2 minus negative 6, it's really 2 plus 6, which is 8, and then 8 squared is 64. Over here we're looking at 17 minus 2, which is 15, and 15 squared I believe is 225. So 64 plus 225 happens to be, let's see, 289. And 289, the square root of 289 happens to be 17, and then you're done. So that's how you would do the distance formula, and you would essentially do the same thing with problem number 8 and problem number 9. Okay, so these are some sort of random algebra problems that can be useful to go over. So they want to know 3x plus 6 equals 30. What's the value of x plus 2? Well, you could definitely just find x first. So you could always solve for x. That's fine. Subtract 6 from both sides. You'd get 3x equals 24. X would therefore be 8. And remember, they're not asking for x. They're asking for x plus 2. So that would be 8 plus 2 equals 10. So you would definitely be done in that case. There is a little bit of a shortcut here, though, because if we were to look at, 3x plus 6 equals 30, well, the reality is you could have factored out a 3, and it would have become in the parentheses x plus 2. And that is what you're looking for, right? I mean, they want to know, what's x plus 2? Well, it's actually right there. So all you have to do is divide both sides by 3, and you would get it, right? You would have x plus 2 equals 10. And that would have been a way to maybe cut to the chase a little bit, right? Divide both sides by 3. The 3's would cancel, leaving you with just x plus 2. 30 divided by 3 is obviously 10. That's that one. All right, a number is raised to the third power, then subtracted from 15 to get 7. So subtracted from is definitely subtraction, but you have to be careful with the term subtracted from. Less than, and let's see, fewer than, I would say. There might be another one I'm not thinking of. But all three of these things mean subtraction, but you have to be careful. You have to reverse the order by which the statement presents the information. So we have a number raised to the third power. So okay, fine, n to the third power, but that's subtracted from 15. So it's not n to the third minus 15. It's 15 minus n to the third, and that's going to equal 7. Once again, when it comes to these statements, you have to kind of flip the order a little bit. All right. So then we want to know, what's the number squared? Well, I don't know. Let's add n to the third. Actually, let's not. Let's subtract 15 from both sides. Okay. So we're just going to keep that n to the third on the left. So we have negative n to the third on the left. And then we have 7 minus 15, which is negative 8. The reality is there's a negative 1 secretly being multiplied to that n to the third. So at this point, let's divide both sides by negative 1. And then what we have as a result is n cubed, or n to the third. Negative 8 divided by negative 1 is positive 8. And if we were to find the cube root of 8, we would realize that n equals 2. Now, one way of going about it is you could ask yourself, what number times itself 3 times gives you 8? Well, 2 times 2 times 2 gives you 8. So therefore, we could say 2 to the third power gives you 8. So, what number to the third power gives you 8? Well, that's 2. Okay. Now, they're not asking for that. They're trying to trap you by putting a 2 here. They're saying, what is that number squared? So we have to do the additional task of doing 2 raised to the second power, and that equals 4. So that's that one. Okay, a 2,000 milliliter can fit, if 2,000 milliliters can fit in a certain glass jar, how many liters can fit in 4.5 of those jars? Well, there are 1,000 milliliters in one single liter. Okay, so what we could do is just imagine these jars. Right, here's a jar, and there's 4.5 of them. Right, 4.5 of them. So let's draw 4 full jars, and then there's a 5th jar, but that one's only half full. So this one is completely full, right? Completely full. Make it blue. Completely full. Completely full. Completely full. Completely full. But this one's half full. Okay? Half. Half full. So apparently each one of these is 2,000 milliliters, aka 2 liters, right? Because 1,000 milliliters is 1 liter, so 2,000 milliliters is 2 liters. So actually, let's just call each one of these 2 liters, might as well just do that. That's 2 liters, this is 2 liters, this is 2 liters, this is 2 liters. This has to be 1 liter because this is half of the normal glass, right? So we have 2 liters, 2 liters, all the way across the board. 2 liters, 2 liters, 2 liters, that. So we're looking at 8 liters plus the extra liter, which is 9 liters. So we are done. Two angles are given as 120 and 60. Which statement is true? Are they complementary? Complementary means they add up to 90. Well, is that true? Does 60 plus 120 equal 90? No. The angles are supplementary. Well, supplementary means the angles add up to 180. Is that true? 60 plus 120, is that 180? Yes, that's true. These could not be true. That could not be true. The bottom line is that's the one. What is the probability that a randomly selected factor of 36 is also a factor of 64? Well, I would say let's find the factors, okay? So 36, you could always do this column thing, 36, and then do the factors. Well, 1 times 36 gives you 36, 2 times 18 gives you 36, 3 times 12 gives you 36, 4 times 9 gives you 36, 5 times nothing, and then 6 times 6 gives you 36, right? So what are the factors of 36? Well, that would be 1, 2, 3, 4. We could say 6. We only need to mention that once, though. 9, 12, 18, and 36. Those are the factors of 36. Well, what about 24? Well, let's write 24 here. 1 times 24 is 24. 2 times 12 is 24. 3 times 8, 4 times 6, and then that's it. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So what is the probability that a randomly selected factor of 36? Well, this is probability, right? This is probability. Now, probability has to do with desired over possible outcomes. Desired outcomes over possible outcomes. In my opinion, it's always better to start with the possible outcomes. In other words, find out how many possible outcomes there are. Well, if you're randomly selecting from the factors of 36, well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes, right? So that's the denominator. But then they're like, what's the probability that if you reached your hand in the bucket and pulled out one of these numbers, it would also be a factor of 24? Well, I don't know. How many factors do they have in common? Certainly 1. Certainly 2. 3 they have in common. 4 they have in common. 6 they have in common. 12 they have in common. And that's it. Okay, so how many common factors? 1, 2, 3, 4, 5, and finally 6. So 6 out of those 9 happen to be a common factor with the factors of 24. So this is actually the answer, except you're going to want to reduce that to 2 over 3. Okay, how many more prime numbers exist between 10 and 20 than do between 20 and 30? Well, the prime numbers start with 2, then we have 3, then we have 5, then we have 7, then we have 11, 13, 17, 19, not 21, 23, not 25, not 27, 29. And then, after that, it would be like 31, But we actually don't need that one because we're only interested up to 30, right? So that one we don't need. So how many more prime numbers exist between 10 and 20? Well, that would be these. All right, 1, 2, 3, 4. Then there are between 20 and 30. So that would be these, okay? So there are 4 here, and then there are 2 here, and 4 minus 2 is obviously 2, okay? Because we want to know how many more of these are there than these. So I addressed prime numbers in the way beginning of this video, okay? Prime numbers are numbers that are only divisible by themselves in 1. I'll also keep in mind the first prime number is 2. It's also the only even prime number, which is very strange. What is the average of the least common multiple and greatest common factor of 9 and 30? So earlier in this video, we covered the upside down cake method. So the average of the least common multiple, well, let's find the least common multiple and the greatest common factor. Well, we're dealing with 9 and 30. If we do the upside down cake method, you just ask yourself, okay, well, what goes into 9 and 30? Well, 3 does. 9 divided by 3 is 3, 30 divided by 3 is 10, and then we are sort of, done here because there's no common factors between 3 and 10 other than 1, okay? So if we want the greatest common factor, all we need to do is pay attention to this number to the side. So the greatest common factor is 3. The least common multiple, though, is a different story. You have to pay attention to this number, and this number, and you actually have to multiply all these. 3 times 3 is 9. 9 times 10 is 90. So the least common multiple happens to be 90, okay? So what's the average of these two? Well, you got to average these, okay? So you got to go 90 plus 3 divided by 2. That's what you have to do. And then you're going to end up with 93 over 2, which is right there. Okay, a taxi cab company in New York City uses the values below to calculate their fares. So there's a flat fee. In other words, no matter what, you have to pay $2.50. But then, depending on how many half miles you go, it's 0.4. So I'm going to say per mile. So per mile, then, it's 80 cents, right? So whenever they give you the half mile, you might want to just be like, all right, fine. But what is that per mile? Okay, what is the total cost for a 6.5 mile trip? Well, it's definitely going to be the flat fee, which is, $2.50, which is what you have to pay no matter what, plus 80 cents times the amount of miles you went. Well, you went 6.5 miles, and that's going to be the answer. Okay, so the question is, well, what's 0.8, 80 cents times 6.5? So that would be 0.8 times 6.5 happens to be 5.2. And that is 5.2 plus 250 happens to be 7.7. Okay, so that's that. Okay, once again, flat fee per half mile. It's still the same deal. We're going to say it's 80 cents per mile. 80 cents. Okay, grabs a cab from this company and takes a 10-mile trip. After the trip, he tips the driver 10% of the subtotal. What is the grand total that he spent? So, well, how much would the trip have cost him without the tip? Well, that would be the flat fee plus 0.80 times 10 miles, right? That's the sort of normal cost of the trip. Well, that's going to be, 250 plus 10 times 80 is 8, right? So that's $8. And then therefore it's $10.50. That's how much it would have cost him if he did not tip the company. However, he added a 10% tip on top of that. So the question is, what is 10% of 1050? Well, you could always use the part over whole situation, and that equals percent over 100. So the part we don't know. We don't know what 10% of 1050 is yet. We know that the whole is 1050 though. We know that the percentage that we're working with is 10, and then you always have 100 down below. So if you were to cross multiply, that would be 100 times x. If you were to multiply 10 times 1050, that would be 105 dividing both sides by 100 would give you $1.05, okay? And therefore, the literal monetary amount of the tip was $1.05, okay? $1.05. So how much did the entire trip cost, when you add that tip on top of this monetary fee? Well, that would be $11.55, right? Because 10.50 plus the tip is $11.55, and that's right here. Okay, 14/25 is closest to what percent? Well, one way to do it is to recognize that percents are always a fraction where 100 is in the denominator, okay? And whatever the numerator is here is the literal percentage. So if I was to say, what's 30% as a fraction? Well, that's really just 30 over 100. And we could reduce that, but it is true that 30% is 30 over 100, okay? So one thing we could do, actually, that's, in my opinion, a very fast way, is to literally just take 14/25 and set it equal to x over 100. It's like, this is what percent? Well, I don't know, it's x percent. So that's one thing you could do. All right, now there's a shortcut way of going about this, but let's just stick with the old cross multiplication. So it's 25x equals 1400. If you were to divide both sides by 25, 1400 divided by 25 is 56. So that is the answer right there. 2 points are given. 3, 4, and 6, 8. Okay, great. What's the slope? Okay, well, we already discussed the slope formula. The slope formula, as a reminder, is y2 minus y1 all over x2 minus x1. We have x1, y1, x2, y2. Okay, and we will call this x1, y1. We will call this x2, y2. So when we're figuring out the slope, it's going to be something minus something all over something minus something. Well, it's going to be y2 minus y1. So that would be 4 minus 8. And then x2 minus x1. So that would be 3 minus 6. And that turns into 4 minus 8 is -4. 3 minus 6 is -3. The negatives cancel, giving us 4/3, and then we are done. Solve the equation for t. Okay. Well, a good idea when you have these annoying denominators, and this is something we did earlier in the video as well, a good idea is to clear the fractions, which means multiply literally everything by that actual number, that's down there. Multiply everything by that. So 3 times, when I multiply 3 times the first term, the 3's cancel. When I multiply 3 times the second term, the 3's cancel. And when I multiply 3 times that, that's going to become 6t, and 3 times that, that's going to become -18. So what we end up with is t plus 8 equals 6t minus 18. Now, because we've cleared these denominators away, we have sort of an easier equation to work with, okay? Now, let's go ahead and get the t's on the left. We can subtract 6t from both sides. You're going to end up with -5t plus 8 equals -18. We can then subtract 8 from both sides. As a result of that, we would have -5t, because these would cancel, equals -26. And then dividing both sides by -5 would cancel those, and then we would have t equals 26 over 5, because the negatives would cancel here. So we'd have 26 over 5, which is right there. So we are done. Okay, factory A produces 12 tons of waste every 4 weeks. Factory B, blah, blah, blah. 2 weeks. Factory C, blah, blah, blah. After 4 months, which factory produces the most waste? Um, hmm. Yeah, so I would say this is a unit rate problem. Let's analyze factory A. So we'll put waste per 1 week. We're going to analyze what's the waste per 1 week. Okay. Well, in order to figure out the waste per week for factory A, it would be 12 tons divided by 4 weeks, and that equals 3. So factory A produces 3 tons per week. Okay. So factory B apparently produces 5 tons every 2 weeks. So if we want to know how many tons it produces for 1 week, it would be 5 divided by 2, and that's equal to 2.5. So factory B produces 2.5 tons per week. And then finally, factory C apparently produces 9 tons every 6 weeks. So if we want to know how many tons it produces in 1 week, it would be 9 divided by 6, and that's equal to 3 over 2, aka 1.5, okay, tons per week. So I know they're saying after 4 months, who produces the most waste, but my thought is like, my thought is, since we now know the per week rate, whatever the largest per week rate is the one that produces the most waste. So that's this one, okay? Because every week that goes by, factory A produces 3 tons. Every week that goes by, factory B only produces 2.5. Factory C only produces 1.5. So clearly, after 4 months, A is going to be the winner, okay? So that's one way of going about this. There's actually multiple ways of going about this, but I would find what's called the unit rate. In other words, okay, great, 12 tons for every 4 weeks. Well, how much for 1 week? Let's figure that out, because that's going to make our life easier. That's going to make all future calculations easier. So therefore, that's the one. Okay. What is the closest value of the expression, blah, blah, blah? Okay, well, I know this looks crazy. The truth is you could just multiply straight across, get some huge number, and then reduce it. Okay. But, that's terrible. That's terrible. Because these are so big, you're not going to want to do that. The reality is that you can just simplify these. First of all, the zeros can go. That zero cancels that. These zeros cancel. So in reality, this guy could reduce to 2 over 13. Okay. Now, I know it's kind of weird. Like, just cancel the zeros. Well, yeah, you can cancel the zeros, because what you're really doing is you're just dividing the top and bottom by 100. You're reducing this fraction by dividing 200 by 100 and dividing 13 by 100, 1300 by 100. And then that results in 2 over 13. Similarly, you can divide the top and bottom by 1,000 here, which sort of amounts to getting rid of the 3 zeros. And next thing you know, you have 13 over 2, right? So that is a beautiful thing, because those two numbers are way easier to work with than these two numbers. But at this point, you could then recognize that you could do this cross cancellation, where these cancel, that becomes a 1, that becomes a 1, and these cancel, that becomes a 1, that becomes a 1. So therefore, when you multiply this, you would just multiply straight across, but it's going to be 1 times 1, which is just 1. And then down here, you're going to have 1 times 1, which is just 1, and that equals 1. Okay, so that's that one. Boom. A number is increased by 10%. The result is then lowered by 10% twice, which expression correctly shows the results after all the changes. So that is a nightmare, right? That is a nightmare. Well, it's like x. So in other words, x is the original number. You know, when they give you this x, just know that they mean the original number. We're going to say that x equals 100 because we're actually allowed to make up our own number. If you have a multiple choice problem, where there's a variable featured in the multiple choice answers, there's a good chance you could actually make up your own numbers for whatever that x is, okay? So we're going to call x 100 because that's a very easy number to work with when you're doing percentage problems. So number is increased by 10%. Okay, if we increased 100 by 10%, wouldn't it then become 110 after the first move, right? And then we lower this by 10%. So this number gets lowered by 10%. Okay, so we add 10%, but now we're lowering it by 10%. Now, what's 10% of 110? What is 10% of 110? We're not looking at 10% of 100, right? We now have 110 units, and we want to know what's 10% of that because we're going to take it away. So I would say part over whole equals percent over 100. We know that the percent we're dealing with is 10. 10 over 100, x over 110. You could then cross multiply it up. Next thing you know, you got 100x equals 110 times 10. That's 1100. Divide both sides by 100 would give you 11. So really, it's minus 11. And then, therefore, we would end up with 99. But then we're not done because it got lowered by 10% again, right? 10% twice. So we got to take away 10% of 99 from 99. Well, what is 10% of 99? Well, we could do part over whole. In this case, the whole is 99. We're still looking at 10 over 100. And at that point, cross multiplying gives us 100x equals 990. Divide both sides by 100. We're going to get 9.9. Okay, 9.9. So therefore, 10% of 99 is 9.9, which means we're going to take away 10% of that, which is the same as subtracting 9.9. So 99 minus 9.9. That's 99.0 minus 9.9. That could turn into a 10. It could turn into an 8. 10 minus 9 is 1. 18 minus 9. And we have that turns into an 8. So 89.1. So the result turns into 89.1. But the question is, which expression correctly shows this result? So in other words, which of these expressions equals 89.1 if x was 100? Okay, so these two pieces of information are going to be key. The fact is x equals 100 because we chose that. And then our result when x is 100 is 89.1. So which of these is such that when you plug in 100 for x, you're going to get 89.1? Well, you will quickly see that answer choice B would work because 0.891 times 100 is indeed 89.1. Okay, so that's the answer. Okay, so these are function type problems. It's important to not get freaked out when you see G of 5. Literally all that means is plug in 5 for x, okay? So if you see something like this, you have negative 2, not times x, but times 5, plus 3 times 5, and that's negative 10 plus 15, and that equals 5, and then you are done. This one has to do with the absolute values of x. Okay, f of negative 3. Plug in negative 3 for x. That's all you have to do. Instead of x squared, you're going to write negative 3 squared. So we'll analyze this. Absolute value of negative 3 is literally just positive 3, but then it's a negative positive 3, so that's going to become negative 3. Analyzing this, negative 3 times negative 3 is positive 9, so that's going to become plus 9, and that becomes 6. Negative 3 plus 9 is 6, so that's the answer there. Looking at this one, f of x equals 2x, g of x equals 0.5x. Okay, what's the value of f of g of 4? Okay, once again, I understand this can be confusing. This is not multiplication here. Any of you students who are unfamiliar with functions, don't worry about it. This might as well just say y equals 2x or y equals 0.5x. But the bottom line is you just need to know how to navigate the situation. First thing you got to do, if they give you f of g of 4, where there's literally a number in there, see that there's a 4 in there, that's called a composite function, okay, because there's a function within a function. You see this little 4 in there, all that means is find g of 4 first. Find g of 4. Now g of 4, as I told you before, all you have to do is take 4 and plug it in for x over here. So g of 4 instead of 0.5x, I'm going to write 0.54. Now 0.5 times 4 is 2. So when they ask you, what is f of g of 4? What they're really asking is, what is f of 2? That's what they're really asking, okay? Because g of 4, we just found it. We found g of 4. G of 4 is 2, so then you put 2 in there. So it's f of 2. Well, what's f of 2? Well, you look at this function called f of x, and then you go ahead and write, okay, f of 2 is going to be equal to 2 times not x, but 2, and that equals 4. So that's the answer. Okay, name two acute angles in the figure. Well, let's see, QRT and VRW. QRT, that's acute, and VRW, that's acute. Now, acute means less than 90. So QRT is this one. Okay, I'll color code it in red. VRW in green is this one. All right. VRW, QRT. Now, they are both acute because they are both less than 90 degrees. QRT is 45 degrees. VRW is 60 degrees. Now, let's see about this one. QRT, that's definitely acute, but this is VRS. VRS. No, VRS is 90 degrees. QRV, well, that's already 90 degrees. Acute angles are less than 90. QRW, well, that's more than 90, okay? QRW is a huge angle. QRW is this big angle with this huge measure, and that huge measure is 45 plus 45 plus 60. That's a huge degree measure, which is way more than 90, so that's gone. All right, hopefully that makes sense. Name a pair of complementary. When they say complementary, they mean two angles that add up to 90 degrees. So let's find out. HIK and JIK. Well, HIK, let's color code. HIK is red. JIK is yellow. HIK, there's that one. Okay. JIK, where's that? JIK. JIK. Okay, do these angle measures add up to 90 degrees? Well, it's 45 plus, but the problem is JIK is this huge angle. 45, this is 45, but this is 90 plus 45, which is 135. And 135 plus 45 is 180. It's not 90. We're looking for complementary angles. Complementary angles add up to 90 degrees. Okay, so answer choice A is out. Let's use color coding here. We got the blue angle, we got the yellow angle. The blue angle, LIK, LIK, that's this, and then KIJ, KIJ. Well, that's this whole big thing. But the bottom line is, we know this can't be true because LIK is already 90. So 90 plus something else is not going to get you 90. It's going to get you something more than 90. So gone. Get it out of here. I don't like it. Boom. Out of here. All right, looking at this one. HIK, color coded up. We got green and we got yellow this time. HIK. HIK. H-I-K, okay. L-I-J. L-I-J. Okay, well, uh, H-I-K is 45, great. Plus this 45, is that 90? Yes. Okay, so when you add the green angle measure plus the yellow angle measure, that will be 90 degrees, so those two angles are complementary. Okay. Supplementary means they add up to 180. Okay, name two pairs of supplementary angles in the figure. Okay, so color code: red, blue, yellow, green. H-I-K, H-I-K, L-I-J, L-I-J. Okay. So two pairs of supplementary angles. Well, already those are not supplementary. Those are complementary, just these two pairs, because this is the first pair they presented. And already they're not supplementary because HIK plus LIJ is 45 plus 45. Now that's 90. That doesn't equal 180. We're looking for supplementary angles. Supplementary angles equal 180. So answer choice A is already gone. We can kind of get rid of that very quickly. Okay. Let's look at this one. I should really be doing that. I should be going A and then B. So color coding, once again, we've got red, we've got blue, we've got green, or yellow, we've got green. Okay, red, L-I-K, L-I-K. Okay, and then K-I-J, that's blue, K-I-J. Okay. Well, let's analyze it. LIK is 90, okay? And then the KIJ is this big angle here, okay? And that's going to be 90 plus 45, which is 135. And when you add 90 plus 135, they do not equal 180. So already that one's gone also because we're looking for supplementary and two pairs of supplementary angles. Well, so far we've only had to investigate the first pair, and we're already ruling these answers out because the first pair is not supplementary. They're not supplementary. So answer choice B is gone. All right, let me just get rid of that. All right, red, yellow, blue, and green. Starting with the red, H-I-K, H-I-K, H-I-L, H-I-L, which is this huge guy, okay? So H-I-K is that 45 degrees, whereas H-I-L is this big guy, which is 135. Now, do they add up to 180? Does 45 plus 135 add up to 180? Yes. So far, so good. Answer choice C is looking pretty good. Let's look at, however, the other pair, okay? So we have KIL, 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 that's 90, okay, plus JIK, JIK. So KIL is 90, but JIK is this large guy, which is 135, right? So do they add up to 180? 90 plus 135, that's a 135. No, that goes past 180, so that answer is also wrong. Now, obviously, process of elimination would have us correctly answer D as the answer, but I say let's just do it just to feel good about it. So let's see. HIK, that's red. HIK is 45. JIK is 135. So yes, they would add up to 180. Okay. So that's the first pair. Looking at the second pair, we have HIL, that's this big guy, that's 135 degrees. If you were to add, this 90 plus this 45, and then we have LIJ, that's 45 degrees. Do they add up to 180? Yes, 135 plus 45 is 180. Okay. In the figure, angle 1 and angle 3 are vertical. That means they're directly across from each other, and by the way, they are equal to each other. Angle 2 and angle 4, they're across from each other. They're also vertical. The measure of angle 4 is 100, so that's 100, which makes this 100 because that's vertical angles are equal. Find the measure of angle 2. Yeah, 100. Done. Okay, that's all I need to know. Let's see. In the figure, the angles are formed by a transversal and two parallel lines. Which angles seem to be congruent? Okay, so the two parallel lines are these guys. And parallel means they're like train tracks. They go on forever and they never touch. Anytime you have a transversal, that's this obnoxious line that's cutting across the train tracks. That's what they mean by transversal. Now, whenever that happens, you have formed 8 sort of small sharp angles. See those green dots? And you have formed 8 big fat blue angles. Okay. All right, see how that's kind of a small, sharp angle? It's acute. It's less than 90 degrees. And then this one is also acute. It's less than 90 degrees. Same with that one. Same with that one, right? But then you look at the blue dots. That's more than 90. That's obtuse. So is this one. So is this one. So is this one. So that happens often, okay? Now, it's the case that if these lines are parallel, then all the acute angles, all the green dots, are going to equal each other. All the blue dots, all the obtuse angles are going to equal each other. All right, that's what you need to know. So is it the case that angle 1, this is a congruent symbol. That basically means the measure of the angles are the same. Is it the case that the measure of angle 1 is the same as the measure of angle 3? Yes, so that's good. Is it the case that they also equal the measure of angle 5 and angle 7? Yes, this whole line checks out. Is it the case that the measure of angle 2 is the same as the measure of angle 4? Well, 2 and 4, yes, they both get the green dot, so that checks out, right? Is it the case that that's also equal to 6 and 8? Well, yes, they get the green dot as well. So we were lucky. Answer choice A totally works, okay? But that's the insight you need. So just to reiterate, you have two parallel lines. I'll draw them a little differently this time just to make sure that we're aware of the universal principle of this. You have two parallel lines, you have a transversal. In that moment, you have formed 8 of these acute angles, and you have formed 8 of these obtuse angles. And it is the case that all of the acute angles equal each other, and all of the obtuse angles equal each other. Okay. So, measure of angle ABC. Right. So, if you were to even look at the diagram that I just drew, okay, this diagram, in a way, kind of looks like this diagram. I didn't mean to do that. But do you see how this is essentially x right here? And then this corresponds with 3x minus 70. So, and do you see how this red acute angle equals this red acute angle? So that's what they're doing. They're basically saying, oh, these are parallel. And it's up to you to realize, oh crap, this angle is equal to that angle. This angle is equal to that angle, which means that um, you can literally set them equal to each other. X equals 3x minus 70. And then you can just literally solve for x. So you can subtract 3x from both sides. You would get negative 2x equals negative 70. You could divide both sides by negative 2. You would end up with x equals negative 70 divided by negative 2 is positive 35. So then you would be done with finding x. Now, x is equal to ABC. I know they're asking for ABC, which is this guy. But keep in mind, x, which we just found, is equal to that, right? X is equal to that. So therefore, ABC is actually 35. Now, in case that makes you nervous and you feel like you don't want to just say that, well, you can always plug in 35 in for x here. If you want to confirm it, just be like, all right, fine, 3 times 35 minus 70. What does that equal? Well, you would very quickly realize that that equals 35. Okay, that's that. Find n in the obtuse triangle. So first of all, the fact that it's obtuse is irrelevant. Obtuse just means there's one angle that's more than 90. The bottom line is the piece of information you need to know is that when you add all of these angle measures, it should add up to 180. That's the case with all triangles in the universe, even this one. All triangles in the universe, when you add all the interior angles, it's going to equal 180. So we got 136 plus 24 plus n equals 180. So combining like terms here, 136 plus 24, that's going to be 160, I believe. Is that right? Yeah. 160 plus n equals 180. Subtracting 160 from both sides gives me 20, so n equals 20. So that's that. Okay, find the angle measures in the isosceles. Okay, so they're telling you it's isosceles. Now it is isosceles because that side is equal to that side. That's an isosceles triangle. It is always the case that with isosceles triangles that the base angles are also equal to each other. So sure, that's true. But the truth is, though, that f plus 44 equals 180, right? Because of the same thing we said in the last problem. All the angles add up to 180. All the angles add up to 180. So therefore, 2f plus 44 equals 180. Therefore, 2f equals 136, I believe. Therefore, f equals 68. And therefore, we are done. And then we're moving to the next one. Can a triangle have sides of length 5, 11, and 7? Well, 5, 11, and 7. The rule is that that any of these side lengths has to be less than the sum of the other two sides and greater than the difference of the other two sides. So is 5 less than the sum of 11 and 7? Well, yeah, 11 plus 7 is 18. 5 is certainly less than that. But is 5 greater than the difference between 11 and 7? Well, 11 minus 7 is 4, and 5 is most definitely greater than that. So that checks out. But then you have to do the same investigation with this. Is 11 greater than the sum of these two guys? Well, the sum of 5 plus 7 is 12. No, I'm sorry, is 11 less than the sum of these two guys? And 11 is less than 12, yes. So is 11 greater than the difference between these two? Well, 7 and 5, the difference between these two, 7 minus 5 is 2. So is 11 greater than the difference? Is 11 greater than 2? Well, certainly it is. But then you have to do the final investigation here. Is 7 less than the sum of these two? Well, the sum of 5 plus 11 is 16. 7 is certainly less than that. So is 7 greater than the difference of these two? Well, 11 minus 5 is 6, and 7 is indeed greater than that. So the test checks out across the board. That could be a triangle. What about 4, 2, and 7? Let's do the same investigation with 4, 2, and 7. Well, let's start with 4. Is 4 less than the sum of these two? Well, the sum of 2 and 7 is 9, and 4 is certainly less than that. Is 4 greater than the difference between these two? Well, 7 minus 2 is 5, and 4 is not greater than 5, so this cannot be a triangle, okay? So that's the sort of process you're going to have to practice and figure out in order to solve that, okay? Find the sum of the angle measures in the figure. This is literally just a memorization situation. The sum of all these angles in a triangle is 180, okay? But when it comes to a four-sided figure, okay, the sum of all these angles is 360, okay? That's something I would actually encourage you to remember that. Although I will say, I'm already foreseeing we might need a formula. There is a formula for the sum of interior angles of any shape like that. They call these shapes polygons. So sum of interior angles, there is a formula that we could use, so I'll just talk about it. The sum of interior angles is going to be 180 times n minus 2. Now, n is the number of sides you're dealing with, okay? So if you wanted to know the sum of all the interior angles of these, well, it would have been, the sum is equal to 180 times n minus 2. Well, how many sides are there? 4. 4 minus 2. So it would have been 180 times 4 minus 2 is 2, and that's 360. Okay, so this is a formula that can really come in handy when it comes to the sum of interior angles. Speaking of which, we have a pentagon, and we want to know the angle measures of the regular polygon. So when they say regular, that means that all the side lengths are equal to each other. And when they say regular, that means that all the interior angles are equal to each other. So what would happen? Why don't we just find the sum of all these? Why don't we just find the sum of all the angles and then divide it by 5? Wouldn't that give us G, right? Well, we could totally use the formula that we just mentioned right here. So the sum of these is going to be 180 times 5 minus 2, right? So 180 times 3, and 180 times 3 is 540, okay? So then it's going to be 540 divided by 5 angles, right? Because 540 is what you get when you do G plus G plus G plus G plus G. So 540 divided by 5 should give us G, right? 540 divided by 5. 5 goes into 5 once, minus 5, 0, drop the 4 down. 5 goes into 4 0 times, so 0, subtract that, 4, drop that down. 5 goes into 48 times, so we are looking at 108, and we are done. G is equal to 108. Okay. Give all the names that apply to the figure. Well, definitely a quadrilateral because there's 4 sides. Definitely a parallelogram because the opposite sides are equal. Like, all it takes for it to be a parallelogram is if the opposite sides are equal. This side is equal to that side, and this side happens to be equal to that side. Now, it turns out that all the sides are also equal to each other, so that makes it a rhombus. Okay. Give all the names that apply to this figure. Well, it's definitely a quadrilateral. This side is equal to that side, which makes it almost a parallelogram. This side is equal to that side, so it's a parallelogram for sure. There's 90 degrees at the vertices, which means it's also a rectangle. So we are looking at answer choice C. It's not a rhombus because a rhombus is when all the sides are equal to each other. It's not a square because a square has 90 degrees at the corners, but all the sides are equal to each other. Okay. Quadrilateral, parallelogram, rhombus, not a rhombus. Quadrilateral, parallelogram. A is true, but there's one more thing we could say. We could also say it's a rectangle. Find the measure of each angle in a regular 18gon. Well, the sum of the interior angles is going to be 180 times 18 minus 2. So that's 180. 18gon means it's an 18-sided figure. Okay. So it's going to be 18 minus 2, which is 16. 180 times 16 is 2,888. 2880. Okay, but we want the measure of each angle in a regular. So it's regular, so all the interior angles are equal to each other. And we want the measure of each angle. We found the sum of all those angles. So we will have to divide 2880 by 18 now in order to find the measure of each angle. And if we were to do that, we would quickly see it's 160. So each angle is 160. Find the coordinates of the midpoint CM with endpoints 1, -6 and 7, 5. Okay, so that is the midpoint formula. Midpoint formula is this. So we have x1 plus x2 y1 plus y2. We'll call this x1, y1. We'll call this x2, y2. And then you just literally plug it in. We are going to have 1 plus x2, which is 7, all over 2. And then we're going to have y1, which is negative 6, plus 5 over 2. And let's just see, that would be 8 over 2, which is 4, which makes C the answer, if we're going to be quick with it, right? So, 1 plus 7 is 8, 8 over 2 is 4, so therefore that's the only answer. That doesn't work, that doesn't work, that doesn't work. Okay, find the measure of angle RST. Well, RST, where is it? RST. Okay. Well, remember how I said when you have parallel lines and you have a transversal cutting across, you have formed these little red acute angles, and they are all equal to each other. You have also formed these green obtuse angles, and they are equal to each other. So look, this red guy is equal to this red guy. So this 3x is equal to this 4x minus 24. So we're going to say that. We're going to say 3x equals 4x minus 24. Let's subtract 4x from both sides, giving us negative x equals negative 24. Dividing both sides by negative 1. Dividing both sides by negative 1. X equals positive 24 because the negative 1 cancels with the negative symbol. So therefore, x is 24. Now, they're not asking for x. They're trying to trick you. See that? I put 24 here. They're trying to trick you. They're not asking for x. They're asking for RST. RST is 3x. So it's going to be 3 times 24, which is 72. Okay? Got to be careful with that. What is the distance between points 2, negative 3 and 0, 8? Well, the distance formula is this x2 minus x1 squared plus y2 minus y1 squared. So that would be, let's see, let's call this x1, y1. We'll call this x2, y2. Okay, so x2 is 0 minus y2 is 2, minus x1 rather. Y2 is 8 minus y1 is minus negative 3. So that's going to be negative 2 squared, which we will worry about soon. Over here, 8 minus negative 3 is really 8 plus 3, which is really 11. So it's going to be 11 squared. So we will have 4 plus 121, and that would be 125. So that is the square root of 125. Well, 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 140, 144. So we know, these two numbers are key. The square root of 144 is 12. The square root of 121 is 11. So the square root of 125 has to be between 12 and 11. So the answer should be like 11 point something. So it's probably D. Okay. That's how you could kind of do that without a calculator. Get clear on some of the perfect squares. 10 squared is that. 11 squared is that. 12 squared is that. Okay, that means the square root of 144 is 12. That means the square root of 121 is 11. We're looking at the square root of 125, so it's got to be between 11, got to be between 11 and 12 because 125 is between 144 and 121. What are the coordinates of the image of the point after dilation by a scale factor of 3 with the origin as the center of dilation followed by a translation over the y-axis? Okay, so this has to be a typo. It shouldn't be a translation. I'm pretty sure this is going to be a reflection. Reflection. Now, what do they mean by all this? Well, basically, you have a point, negative 6, negative 2. The negative 6, negative 2. It's right there, okay? What they're saying is this got dilated by a scale factor of 3. That means that you multiplied each of these coordinates by 3. So it's -6, -2. So that's going to become the new sort of image is going to become -18, comma, -6 now, because all you're doing is taking that scale factor of 3 and multiplying it by the coordinates. So the new coordinates are now -18, -6. Now that would put it over here, okay, -18, -6. Okay, but then what they're saying is we do this other thing where we reflect it over the y-axis. Well, here's the y-axis, which means we're going to reflect it over here, okay? Now what that results in is a point over here. So that's going to become +18, comma, -6. Okay, so this is the visual way of understanding what they're talking about. You start with -6, comma, -2. We dilate it by a scale factor of 3, which means we blew it out to here by multiplying these coordinates by 3. Then we reflected it over the y-axis, where it now reflects across, and it's at 18, -6. So that should be the answer right there. Which is a product of this. Okay, so well, the good news is even though it looks intimidating, if you want to multiply these things, it's actually not that bad. Let's take it down here. So we have 3.29 times 10 to the 19th times, and we'll keep that in parentheses, times 7.61 times 10 to the 33rd. So basically, what you could do is just kind of multiply these guys separately and multiply these guys separately. So when you multiply the 10 things, you just keep the base, 10 to the 19th times 10 to the 33. You just keep the base and add the exponents. So that's going to become 52 up there. Then we have 3.29 times 7.61, which is 25.0369. Now the problem is for it to be in scientific notation, which is what they want, this decimal needs to be over here. So if you have to, at the end of the process, move the decimal to the left, well, then you have to bump this up 1. Okay, that's how it works. If you move the decimal to the left, you have to bump it up however many spaces you're moving it over. If we had to move this decimal place 3 times to the left, we would have had to add 3 to that 52. But since we only had to move the decimal once to the left, then all we have to do is just bump up that exponent of 52 up by 1. So that's going to become 2.50369 times 10 to the 53. Okay, so that is right here. Okay, that's right there. Okay. Get rid of some of this stuff. Clean it up a little bit. Actually, leave that answer there. Okay, what is the square root of 112 rounded to the nearest tenth? Well, remember I said 10 squared is 100. Therefore, the square root of 100 equals 10. I also said 11 squared equals 121. Therefore, the square root of 121 equals 11. Now, we know that square root of 112 is somewhere in between the square root of 100 and 121. So the result has to be between 10 and 11. Now, let's see. It's definitely not this, but then we have to narrow it down to this. Well, 10.9 is really close to 11. Right? So that would mean that it should be a square root of a number that's really close to 121. In my opinion, 112 is really not that close to 121. So just instinctively, I'm going to say that's gone. It's this one because 10.9 is basically 11, okay? And 11 squared is 121, not 112. Which order pair lies on the line that represents the equation? These are pretty easy. I mean, the reality is yeah, this is a line, You could graph it, you could look at the graph and see which point is on the line, or you can remember that all you have to do is just test by plugging in, the x coordinate here and the y coordinate here and seeing if it would work. Well, let's look at the first one. What happens when we plug in 2 for x and -3 for y? Well, 2 for x and -3 for y. Does that result in a true statement? -3 equals 2 minus 5. Is that -3? Is that true? Yes, it is true. Therefore, this is the answer. Basically, you would see if you investigated -2 and 3, it would not work. If you plugged in -2 for x and 3 for y, it would result in a false statement. In fact, let's go ahead and do it just to confirm it, and then we'll move on to the next problem. So just to confirm that some of these won't work, in fact, all of them won't work. Just to confirm it, we're going to put, what is it? For answer choice B, let's investigate B. We're going to put -2 there, and we're going to put 3 there, and let's see if that works. 3 equals -2 minus 5 is -7. That does not work, so that's an unhappy face. So that is why this one is gone. All right, which set of order pairs represent the function? Okay, so it's important to not get thrown off by this kind of a question. This kind of a question is super easy, okay? You only need to know the rule, and the rule says, in order for it to be a function, you cannot have any repeat x coordinates. So another way of saying that is, if you have repeat x coordinates, it's not a function. So let's look at this one. Are there any repeat x coordinates? We have a 2, we have a 1, we have a 0, we have a 1. So we have a 1, we have a 1. That's a repeat x coordinate situation, so that's gone. Looking at answer choice B, we have a 0, we have a 1, we have a 2, we have a 3. There are no repeat x coordinates, therefore that's the answer, but let's still verify these. X coordinate of 2, 3, 5, and 5. So the repeat x coordinate here, that's why that one is gone. Okay, we have a x coordinate of 5, 4, 1, and 1. We have the repeat there, so this one is gone. So as long as you remember that rule, then you will very quickly see what the answer is. Okay, what's missing from the table? Well, often patterns are helpful, right? I don't know, it seems to go up by 13 every time. We go 1 plus 13 is 14. 4 plus 13 is 53. I don't know. What's 14 plus 13? Right? I mean, that seems like what it's got to be, right? And then 27 plus 13, does that give us 40? Well, yes, it does. So, yeah, pattern. Automobile traveled 320 miles in 6 hours. So speed times time equals distance. That's what you need to remember. Okay, so apparently we went a certain speed, we'll call it x, for 6 hours, and we went 320 miles. So what does x equal? Well, that's going to be 320 divided by 6. That's going to be, I don't think 320 is divisible by 6, so that's going to be 53 point something, point blah. So it's got to be that one. You could always verify that. 320 divided by 6 is 53 and a remainder, so it's got to be that. Okay. So earlier in this video, I had talked about how anytime you have a negative exponent, you take the number and you shove it down below, and then you change the sign of the exponent. Now, -2 raised to the 4th power, that's -2. Let's investigate. It's -2 times -2 times -2 times -2. And that's going to be 4 times 4, which is just a positive 16. So this becomes 1 over 16, which is right there. What are the coordinates of the 4th vertex of a square with vertices, blah, 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 blah? Well, you can kind of get a sense of what's going on by graphing this stuff. So we have -2, 5, -2, 5, that's right there. We have 4, 5, 4, 5, that's right there. We have 4, -8, so that's down here. 4, -8. It's not really drawing the scale. So this one has to be down here. That's got to be -2, -8, if that makes any sense, because we know that this lines up with this one, which gives it the x-coordinate of -2. And we know that the y-coordinate lines up with this y-coordinate, which gives it a y-coordinate of -8. So we're looking at -2, -8. So looking at this, point A has coordinates -2, blah, blah, blah. Find the coordinates of the midpoint. Okay, so that's a midpoint formula. Midpoint formula says x1 plus x2 all over 2, comma, y1 plus y2 all over 2. So it's something going to be over 2 over 2. We'll call that x1, y1. We'll call that x2, y2. So we are looking at -2 plus 3. We are looking at 2 plus 0. And that would give us -2 plus 3 is 1 over 2. So the first coordinate is 1/2, which makes C the answer already. We are done. A, B, C, D is equal to L, M, N, O. Okay, so what that means is A and B correspond with L and M. So A, B, this one, corresponds with L, M. We'll color code it. We also know that CD corresponds with NO because of the way it's written. So CD corresponds with NO right there. We also know that AD corresponds with LO, so AD corresponds with LO, and we want the value of R. So that green piece of information is this green, the AD and the LO, that's our ticket, because apparently this is the same size as this. This means congruent. This symbol right here means congruent. So that means that these things are the same size, which means that the side lengths are the same, right? So that means that 13 has to equal 2R. So 13 equals 2R. R therefore equals 6.5. 6.5 right there. Great. What are the coordinates of the image of the point blah, blah, blah after a 90-degree rotation followed by translation 3 units to the right? So rules like this will be helpful. So I believe that in this case, they're talking about a 90-degree rotation clockwise. So we are looking at the top row. Now, what does this say? It says that whenever you take a point, you rotate it 90 degrees clockwise, you have the original point, but then you turn it into this, okay, where the y goes out front and then the x goes in the back, but the x changes the sign, okay? So how would that look in our case? Well, you start with -9, 4, but then all of a sudden, what happened to the x-coordinate? Well, you change the sign and then you put it as the y-coordinate in the next thing. So this is a -9. We're going to change the sign, turn it into a +9, and that's going to go right here, right? What happens with the y-coordinate? Well, according to this, the y-coordinate stays the same sign, but it becomes the x-coordinate of the new point. So we're going to have a 4 right there. So that's the new point after rotating 90 degrees clockwise. Now, if you kind of think about it, it now is right here, right? You have a point right there at 4, 9. But then we do something where we translate that 3 units to the right. So in other words, we take this point and we bring it 3 units in that direction. Well, the y-coordinate would stay the same. If we brought it 3 units over here, the y-coordinate would remain 9 because it's at the same height. But it's that x-coordinate that would change. So you'd be adding 3 to that 4. So the new point is going to become 7, 9. Okay, 7, 9, because we are translating it 3 units to the right. When you say translate, that means you're shifting it over. You're just kind of sliding it over to the right. So that's this. Boom. Okay, let's see. Simplify to tell whether 6 over 16 and 28 over 56 form a proportion. 6 over 16, does that equal 28 over 56? Ultimately, that's the question. Well, you could just divide this by 2, get 3. Divide that by 2, get 8. Divide that by, well, probably actually 28. Divide them both by 28. 28 divided by 28 is 1. 56 divided by 28. I think that's 2. Yeah. So is it the case that 3/8 equals 1/2? No, it's not. So they're not a proportion. That's basically the test. You set the fractions equal to each other, see if they equal each other. Okay, Sal earns $480 per week. Lydia earns $300 per week. Are their salaries proportional? Sal works 40 hours per week and Lydia works 25 hours. So it's going to be money over hours. Let's see. One person is 480. 480 for every 40 hours that he works, and then she gets 300 for every 25 hours she works. And the question is are these equal to each other? Well, this divided by 2 at least is 240. 40 divided by 2 is 20. 240 divided by 2 again is 120. 20 divided by 2 is 10. 120 divided by 2 is 60. 10 divided by 2 is 5. 60 divided by 5 is literally 12, and that's just 1. So ultimately, I know it's kind of ridiculous what I just did, but 480 over 40 is really equal to 12 over 1. So the question is 300 over 25 equal to 12 over 1? Well, 300 divided by 25. let's just cut to that chase. Yeah, that's 12 over 1. Okay, so yes, the salaries are proportional because this fraction does indeed equal that fraction. You might have to reduce each one and just compare it, but you would quickly see that the fractions are equal to each other. You could have also cross multiplied, but I thought maybe that would be fast, even though it wasn't. The Anderson family is preparing for a family reunion. They think they will need 8 juice boxes for every 4 children who attend. How many juice boxes will they need if they're expecting 26? So, juice for children, okay? So the juice would be 8 for every 4. So we want X amount of juice boxes for 26. Well, that would be a matter of cross multiplying. So 4 times X is 4X. 8 times 26. Well, 20 times 8 is 160. 6 times 8 is 48. 160 plus 48 is 208. Divide both sides by 4, you're going to get 52. So we need 52 juice boxes. That's how you do that one. Coordinates of the midpoint. Once again, midpoint formula. I've mentioned this several times in the video, so I'm not going to go over what the formula is again, but it's going to be 1 plus 7. It's going to be negative 6 plus 5, and 1 plus 7 up top is 8 over 2, which is 4. Already that's the answer because the x coordinate is 4. One way of knowing what the proper congruent statement is if the letters match. So we'll call H this 106 guy, and that corresponds with this 106 guy. So H and J should correspond with each other. The G is the 29 degree guy, which corresponds with L. And then finally, the F corresponds with this K right here. Okay, now this is distracting me because there's too many blue circles. So we'll just do that. So we want the red to match with the red and so on. So H is red, but K is green, so that's gone. The F is green, and L is blue, so that's gone. This F is green, right? But the J is red, whereas this F matches with the K. That's what we want. This G, which is blue, matches with the L, which is blue, and then finally H, which is red, matches with the J, which is red, so that's the answer. Okay, find the perimeter of the figure. Well, looks like it's a parallelogram, so this should be 15x, and this should be 9.5x. So therefore, the perimeter is going to be the sum of all those sides. It's going to be, 15x plus another 15x plus 9.5x plus 9.5x. These two would be 30x. These two would be 19x. So we're looking at 49x, which is B. Okay, use a composite figure to estimate the area of the figure. Well, this is kind of a weird problem. I mean, use a composite figure, meaning create shapes that don't exist here but sort of match what we're looking at. What I see is that this yellow side seems to perfectly match this side. So I'm tempted to just find this side, on its own, and then multiply that by 2, and then we'll get this. Now, what I see is, this is just me, okay, but I kind of see a triangle here. I see a triangle. Now, that might be dumb. I don't know. Could be dumb. I also see a triangle here, right? And we need to take into account that whatever this shape is, the area over here is going to be a little bit more, right? But let's find the area of this triangle. Well, the area of this triangle is base 1/2 base times height. So the base is 3. The height is approximately 2.5. So the area of that thing is going to be 1/2 the base times the height. So 1/2 the base, which is 3, times approximately 2.5. So that's going to become 3 over 2 times really, 5, or 5 over 2, right? 5 over 2, which is 15 over 4, okay? I know that's kind of ugly and weird, but we're going to go with it. This one has a base. It's going to be 1/2 base times height also. The base is also 3, but this time the height is this whole sort of height right here. So that's 1, 2, 3. I'd say about 3.5. 0.5. So that's really 1/2 times 3 times, I guess that would be 7 over 2. And that's going to give us 21 over 2, or 21 over 4, actually. Okay. But we need to keep in mind it's going to be a little bit more than that, right? So really, the area on this side is going to be the sum of 15 over 4 plus 21 over 4. Okay, 15 over 4 plus 21 over 4. And that's going to be 30, I guess, 36 over 4. So approximately 9. But we know it's going to be a little bit more than 9, right? It's definitely going to be a little bit more than 9 because of these guys. So we'll say 9 or 10-ish, right? 9 or 10-ish. And if this whole thing is 9 or 10-ish, then this whole thing also is 9 or 10-ish. So that means it's about 20. The whole thing's about 20, and therefore answer choice A. Okay, that's how I would go about it. Any of you at home watching this, if you have a better way, let me know, but I don't mind that way. All right, find the perimeter. Okay, well, the perimeter is going to be a matter of recognizing that all these vertical guys, like that guy plus that guy, is going to be the same as this. Okay, and we can say the sum of all the red ones is going to be the same as the sum of all the yellow ones. And the truth of the matter is, this red side adds up to 12 because it would be this 8 plus this 4. So that's 12. And similarly, we could say that this has to be 12 also. And you could always verify that, okay? You could always verify that this whole thing would add up to 12. Well, it would be 2 plus 2, which is 4, plus this 8, which is 12. So that's kind of a miraculous thing. When you're dealing with these composite figures that have 90 degrees everywhere, you can kind of get away with doing that, which means that this green part is most definitely right, which means that this part up here has to be 12 as well. So the perimeter is literally 12 plus 12 plus 12 plus 12. So 12 times 4 is 48, right? So C, we are done. Okay. Now, if we wanted to find the area, we could break it into pieces. That's a strategy that a lot of people like, break it into pieces like this, and then just find the area of each piece. However, I actually think it would be better for this one to not do that. There's a sort of a different strategy that you could do that would probably be better with this one. And that would be to imagine that it was a complete figure that had no indentations whatsoever. So you can imagine it was literally this complete thing. I guess it would be a square. That's 12 by 12 by 12. I know it doesn't look like a square, but just bear with me. Now, the area of that whole thing would have been 144 because it would have been 12 times 12. But we have to take away these blocks. There's a 4 by 4 block that we have to take away. We got to get rid of that. There's also this block here that we'd have to get rid of, and that's a 6 by 2 block. So that's 16, and that's 12. So it would have been 144 minus 16 minus 12. And that would have been 116. Okay, that's probably the smarter way to get the area. Just treat it like one big thing, and then take away these pieces. Take away these pieces. Okay. The rectangles on a quilt are 2 inches wide and 3 inches long. The perimeter of each rectangle is made by a pattern red thread. If there are 30 rectangles in the quilt, how much red thread will be needed? Okay, so I guess each rectangle um, requires red thread all the way around a perimeter. Okay, so rectangles are 2 by 3. So the perimeter of each of these is going to be 2 plus 2, which is 4, plus 3 plus 3, which is going to be 6. So 4 plus 6 is 10. So the perimeter of each rectangle is 10. And there are 30 of them. So it's going to be 10 times 30, which is 300. I actually kind of wish, I see problems with this question, but I get what they're getting at. Okay. Melanie is making a piece of jewelry that's the shape of a right triangle. The two shorter sides of the piece are 9 and 12. Find the perimeter. Well, that would require you understanding that the smaller sides are these guys. It's not the hypotenuse. Then you have the hypotenuse over here. Now you can always do the Pythagorean theorem. 9 squared plus 12 squared equals c squared. 81 plus 144 equals c squared. And then c squared equals 5, 4 plus 8 is 12, 225. C must therefore be 15. So this has to be 15, and then the perimeter is very easy from there. 9 plus 12 plus 15. Okay, so 9 plus 12 is 21. 21 plus 15 is 36. So you are done with that. Okay, that's the Pythagorean theorem that you had to use first. A squared plus b squared equals c squared. Find the area of the trapezoid in which b, blah, 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 7, okay. Base 2 is 12, the height is that, okay. So the area of any trapezoid is 1/2 base 1 plus base 2 times the height. So we're looking at 1/2. Base 1, they're calling 7, base 2, they are calling 12, that's fine with me. Age is 5, so it's very straightforward, 1/2. 7 plus 12 is 19. And it's going to be 19 times 5. So we are looking at 19 times 5 is 50 plus 45, which is 95. So it's going to be 1/2 of 95. And that is probably this one. Yeah, it's that. 1/2 of 95 is 47.5. Okay, toy box measure 7 yards by 6 by 4. The height of the box changed from 4 yards to 8 yards. How would the volume of the box change? It would double because you have this box, right? You have this box, and the height used to be 4, right? Height used to be 4. And now all of a sudden you just changed it to a height of 8. Well, isn't that the same as just stacking another box on top? Yeah, it's the same. If you increase the height from 4 to 8, that means you're tacking on another 4 units on top of it. So yeah, you're doubling the volume. So boom. Let's see. A county has constructed a conical building to store sand. The cone has a height of 195, diameter, blah, 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 find the volume. So a cone is like this, right? And the volume of a cone is 1/3 pi r squared times height. So 1/3 pi something squared times the height. So the radius is the r in this case, the r, which I'll color code in red, is half of the diameter because the diameter is the full distance across, right? So the radius is half that. So this number needs to be half the diameter. Well, they told us the diameter. The diameter is 307. So that's going to be 153.5. 153.5, because that's half the diameter. And then the height they gave us is 195. Right there, 195. So this is annoying. It's 130, 1/3 times 3.14 because essentially pi is really 3.14. So that's going to be this whole kind of ugly string of numbers being multiplied together. And when you do it, it would become 4 million something. So that would become 4809055.225-ish. Putting commas here, we're looking at approximately 4,008,000. So that's right there. Surface area. So what we want to do, okay, for the surface area of a prism, just find 2 times the area of the base, which we'll call big B, plus the perimeter, which we'll call little p, times the height. Okay, that should work. Now, when I say base, I mean the whole area of the top part and the bottom part. Okay, that's what I mean by base. And when I say perimeter, I mean so when I say perimeter, I mean this yellow perimeter here. So I'll keep that color coded. When I say height, I mean this height, okay? And once again, I'll actually color code and marker. The base is this, okay? So that's what you want to do for the surface area of a prism, okay? So it's going to be 2 times the area of the base. Well, the base is a triangle. We have 2 bases, base here, base here. Base is a triangle, and that's going to be 1/2 base times height of the triangle, not the base of the prism, but the base of the triangle. Well, you could call the base of the triangle, it's a right triangle. Let's kind of look at it. You know, we're gonna transpose this triangle, so it's right here, okay? Apparently that's 34 according to this piece of information, right? So that's 34. This side is apparently 16 according to this piece of information, and that's 30. So this is 30 here. So you could most definitely call this the base, and you could call this purple guy the height, okay? So we'll say that the base is the green guy, which is right here, and this is going to be the purple guy, okay? So we are looking at 30 and 16. Okay, the writing is really small, but there's a 30 and a 16. Plus the perimeter. Now the perimeter is this yellow distance all the way around. So that's going to be 30 plus 30, 34 plus 30, which is 64, plus 16, which is going to be 80, I believe. So that's going to be, 80. And then times the height, right? Times the height. The height is 4.4, which is right there, okay? So there's kind of no way around it. It's sort of an annoying calculation that you have to do, but that's the big picture. 2 times the base plus the perimeter times the height. You just figure out each thing separately, find out what the base is. Well, ultimately, it's going to be that. We could do that off to the side. Not the end of the world if you do that off to the side. In fact, why don't we do it off to the side? Okay, so it's going to be 2 times something plus 80 times 4.4. Okay, because if we do too much at once like this, it might be confusing. So 1/2 30 times 16. Well, 1/2 of 30 is really 15, so it's really 15 times 16, and that turns out to be 240. So this is really 240. Okay, now that's a lot easier to think about, isn't it? Okay, so when you calculate all this, though, you're going to get 832, which is right there. Okay, to determine the amount of wrapping paper needed for a rectangular box, that's the surface area situation. Ryan finds the surface area of the box. How much wrapping paper is needed if the box measures 9 inches by 4 by 6? Okay, so I've talked about this before. Now, when it comes to a rectangular prism, the reality is you could do something similar. You could do 2 times the base plus the perimeter times the height. You know what? Let's stick with that. Okay, we're gonna stick with that because I told you that you can do that for this kind of a prism. I'm going to show you that you can actually do the same thing with this kind of a prism. We do want to label it though. Let's call this 9. We'll call this 4, and we'll call this 6. Now, in this case, we're going to call the base this top part. Okay, and we will kind of draw this situation underneath. So the base would also be this like bottom guy down here. We'll say that the height is this, and we'll say that the perimeter is that, right? Well, 2 times the base, the area of the base. Well, the area of this base is 4 times 6, so that's just going to be 24, right? Pretty easy. Plus the perimeter. Well, what is the perimeter? That's going to be 4 plus 6 plus another 4 plus 6. So that's going to be 12 plus 8. So that should be 20. So that's going to be 20 times the height. The height is 9, right? So there you go. So if you calculate all that, that's going to become 228, which is answer choice A. Now, earlier in this video, I did discuss a different formula for surface area that was 2 times length times width plus width times height plus length times height. And I just want you to know that that would have worked as well. Okay, so it is a prism, so you can use this sort of standard prism surface area formula if you want. That will always work for a prism, but you could also use this general surface area formula for a rectangular prism. That's sort of a different way of tackling it, okay? Now, you're dealing with a prism anytime you have some shape on the bottom and then you launch it into the third dimension by bringing it sort of up like that. Okay, and then the shape on the bottom and top we would call the bases, whereas this would be the height, and this would be the perimeter of the base. Okay, now prisms can be any polygon. I mean, you could have a pentagon down here, okay? You could have a pentagon, and the moment you bring it into the third dimension, you have formed what they call a prism. And then you have the base, which is the pentagons on the top and bottom. You have this height, and then you have the perimeter of the base. And that all goes here, and then you can find the surface area. Okay, so let's see. A farmer needs to find the surface area of a cylindrical silo to determine the amount of paint needed to cover the entire surface. Find the surface area of the silo, which has a radius of blah and a height of blah. Use 3.14 for pi. Hint, only one base of the cylindrical silo will be painted since it's standing on the ground. Okay, so in other words, you have this cylinder thing, okay? And this part is open, okay? Now, typically the surface area of a cylinder would be 2 times the base plus we could say the circumference of the base times the height. Now, the height is this part, okay? So I'll make that red. The circumference is this yellow part, okay? And the base is the area of the top and the bottom, which we will denote in blue, okay? So 2 times the base. Now that's typically the surface area of the cylinder, but we need to remember we're not going to be taking into account the area of 2 bases. We're not going to take into account the surface area of this base and this base because this part's open. So the reality is that we only need one of these bases when we're calculating the surface area. Now I'm just going to say SA for surface area. So in this case, in this special case, we're only going to take into account one base because this top base is open. Okay, so this top base is open, so therefore we don't need to take into account 2 bases. So let's see, the radius is 6 feet, okay? So here it is, we have a radius of 6 feet. The height is 13.5. Use 3.14, blah, blah, blah. So the base area is the area of the circle. Now the area of any circle is pi r squared, okay? And the circumference of any circle is 2 pi r. And we will be multiplying that times the height. So let's kind of fill out some of these values at this point. We are looking at certainly pi times something squared plus 2 times pi times something else. Well, the first 2 parentheses would be the radius, so we know that 6 goes there. And the height in this case is 13.5. So we are looking at 36 pi plus 2 times 13.5. 2 times 13.5 is 27, and 27 times 6. Well, 20 times 6 is 120. 7 times 6 is 42. So we're looking at 162. So it's going to be plus 162 pi. And then we have a matter of adding those. You could kind of treat them like they're like terms. Now, pi is 3.14, which we'll take into account at the end of the process. But in the meantime, you have 36 times something plus 162 times that same thing. In a way, these are just like terms. So you can just go ahead and sort of combine them like you would with like terms. So the unit digit is going to be 8. 6 plus 3 is 9. And then we have this. So we have 198 times pi, which is 198 times 3.14, which is 621.7. Okay, so that's C. So that's how you do that one. Looking at the next problem, find the surface area of the pyramid Round your answers to the nearest tenth. So the surface area of a pyramid is a different formula, and that's going to be the following. So it's going to be the area of the base plus the lateral surface area, which is the surface area around this thing, okay? Sort of the surface area of the sides, okay? So that's going to be 1/2 times the perimeter of the base, okay? That's this yellow part, times the perimeter of the base, times what they call the slant height, and we're going to call that an L, okay? That's for the slant height. Now, the slant height is this distance from the ground floor all the way up the side to the top. Okay, that's the slant height. So the surface area is therefore, the area of this base, which is 10.4 times 10.4, which is 108.16. And we're going to be adding that to 1/2 the perimeter. Now, the perimeter is 10.4 times 4, which is 41.6. And we're going to multiply that times the slant height. Now, they give us the slant height. This slant height right here is 15.5. So we'll just write that here. And when we work all of this out, it would be 430.56. 430.56, which is the first answer. Moving on. Okay, a local water park has two types of season passes. Plan A costs a one-time fee of that for admission plus $10 for parking every trip. Plan B costs a one-time fee of that with 22. How many visits must a person make for Plan A and Plan B to be equal in value? Okay, so the cost of Plan A. So the cost of Plan A is going to be 142 plus, we could say $10 times the amount of trips you take, because it's going to be $10 every time you take a trip. And that's going to be set equal to the cost for Plan B, which is going to be $48 plus $22 for every trip you take. Ultimately, they want to know how many visits must a person make for Plan A and Plan B to be equal. So in other words, what is the one amount of visits that you can make where the amount of visits is the same for both, that would cause the cost to be the same for both. So that would just be a matter of solving for x in this case. So let's go ahead and do that. We're going to subtract 22x from both sides. That would give us 142 minus 12x equals 48. We could then subtract 142 from both sides. That would give us negative 12x equals negative 94. Then we can divide both sides by negative 12. We would end up with x equals 7.8 something. 7.8. So they are, unfortunately, this problem is defective because these numbers result in a situation where you have a decimal. So I would say this is the fault of whoever made the worksheet because this process is correct and it doesn't make sense for there to be 7.8 visits, unfortunately. So this problem is wrong. So moving on to the next one. All right, solve and graph. Well, ultimately you could just treat this like an equation. You could divide both sides by 4. We have h is greater than 8. So the critical value in this case is 8. So you're going to want to see an open circle at positive 8. Well, there's definitely an open circle at positive 8 here. And there's definitely an open circle at positive 8 here. But apparently h is greater than 8. Now, if you recognize the fact that the variable is on the left, you can then treat this inequality symbol like it's an arrow. And this arrow appears to be pointing to the right. So that's going to be the way the arrow in the graph is pointing. So that's right here. So that is the answer right there. Looking at problem number 20. Solve and graph. Well, in this case, you'd want to multiply both sides by negative 3. Multiply both sides by negative 3 right here. And the reason for that is because these 3's would cancel.
We then have C. Now, anytime you multiply or divide both sides of an inequality by a negative number, you have to change the direction of the inequality. So that's going to become C is greater than negative 9. So clearly negative 9 is the critical value in this case. It's going to be an open circle at negative 9. So far there's an open circle at negative 9. So far there's an open circle at negative 9. But we know that C is greater than negative 9. Now, the variable is on the left, which means we could treat this inequality symbol like an arrow. The arrow is pointing to the right. So therefore, we are looking at answer choice B as the correct answer. Okay, let's see. Erin spent $15.30 on ingredients for cookies she's making for the school bake sale. How many cookies must she sell at 0.35 a piece to make a profit? Okay, so the profit is going to be a matter of figuring out the total revenue minus the total expenses. Okay, now the revenue is the literal money that you're bringing in, and we want this number to be more than zero, right? If the profit was just zero, then you're essentially just breaking even. That means that you're pulling in as much money as you're spending. Okay, so ultimately, this is really an inequality where you could set p equal to 0, but you want to make sure, you want to find out what scenario would result in the revenue minus expenses being more than 0, not greater than or equal to 0, but actually more than 0. That's the scenario that we want, okay? So one way of going is you can add E to both sides, add expenses to both sides. Next thing we know, we have R is greater than E. So that should make intuitive sense. We want the revenue to be greater than the expenses. Otherwise, you're not making a profit, right? So let's look at the figures they give us. Erin spent $15.30 on ingredients. Okay, so we know that the expenses are 15.3. And how many cookies must she sell at 0.35 a piece to make a profit? So we want that revenue, which is 0.35 times X amount of cookies you sell, right? We're selling a certain amount of cookies at 0.35 a piece. We want that revenue, because that's how much money we're bringing in. We want that to be greater than the expenses, right? So this is the inequality that we definitely want. So all we have to do at this point is divide both sides by 0.35, and that would be 43.71, okay? So 43.71, so we have to sell at least 44 cookies in order for there to be a profit. If we sold 43 cookies, then it wouldn't be enough, because we need to sell more than 43.71 cookies in order to make a profit. So therefore, answer choice A is the answer. Okay, so that's how that one works. Okay, so looking at problem number 22, which of these sets contains no irrational numbers? Well, pi is an irrational number, so that's gone. Let's see, what else is clearly irrational? Radical 2 is irrational. 8.2 is rational. Radical 3 is irrational. So the answer is C. So for those of you wondering, just know that there's such a thing called irrational numbers. I could sort of give a big crash course on that, but I want to keep moving. But just know that very famous irrational numbers are the square root of 2, square root of 3, square root of 5, and pi. Those are very famous irrational numbers. So the truth is that this features pi, which is a problem. This features the square root of 2. Sure, there's a negative in front, but there's still that square root of 2, which is a problem. This features square root of 3, which is a problem. So by process of elimination, we're looking at answer choice C. Okay, so that is something we can pay attention to. Let's see, which of these sets contains no irrational numbers? Well, I can already tell it's probably answer choice A, but let's take a look. This one features square root of 3, which I already told you is an irrational number. Same with this one. This one features a square root of 2, which I already told you is a famous irrational number. So therefore, answer choice A is the answer. Which formula is used to find the volume of a cylinder? Well, that's definitely going to be, that's just something worth memorizing. Volume of a cylinder is going to be the area of the circular base. This is the volume of a cylinder, is the area of the circular base times the height. Okay? So let's see. Is that represented anywhere? Yes, it is. Answer choice B. So that one is done. Let's see. Solve negative 6m, blah, 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 blah. Tell whether the equation infinitely many, blah, blah, blah. Okay, so let's see. We have a situation where I should probably rewrite that. We're looking at negative 6m minus 6 plus 8m equals negative 5 plus 2m minus 1. Okay, so let's combine like terms on the left. We're looking at negative 2m minus 6 equals negative 5. We should actually combine like terms on the right side as well, now that I'm thinking about it, because we have this negative 5 and negative 1. So we're looking at positive 2m. Looks like it's minus 6. At this point, we could subtract 2m from both sides. We would end up with negative 4m minus 6 equals negative 6. We can then add 6 to both sides, which would give us negative 4m equals 0, it looks like. And then we could divide both sides by negative 4, which would give us m equals 0. And that is one particular solution. So m is literally 0. And that's the answer. And that is one solution. So that's only one solution right there. Okay, looking at problem number 26. The formula for resistance of conductor, blah, 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 is that. Solve for V. In other words, it's a literal equation. They just want you to get this yellow V by itself. Well, how are you going to do that? Well, you would recognize that, I guess that's an I down there, right? You would recognize that V is almost by itself. It's just that we have this I in the way. So we have to get rid of that I. And how do we do that? Well, we just multiply both sides by I. That's what we do. And in doing so, we cancel those. Next thing we know, we have V equals I times R. Okay? V equals I times R. So that's this one right here. Let's see. Solve 4x minus z equals y for x. So we want to get this red x by itself. Well, in order to do that, let's rewrite this one as well. In order to do that, we would have to get at least this term by itself. You know, we're trying to solve for x, so we want to at least get 4x by itself. So we need to get rid of this z here. So how do we do that? Well, we add z to both sides. That's what we do. We end up with 4x is equal to y plus z. But we're not done yet, because at the end of the day, we want to get this x by itself. So we have to divide both sides by 4. So x equals y plus z divided by 4. That is answer choice A, and we are done. Okay, an architect built a scale model of a shopping mall. On the model, a circular fountain is 20 inches tall and 22.5 inches in diameter. The actual fountain is to be 8 feet tall. So that's proportion. So we're going to have height over diameter. And I could have done diameter over height. That's fine. But we're going to do height over diameter. And we are looking at the model fraction and then the real. Okay. So the model is such that it's 20 inches tall, 20 inches, and 22.5 inches in diameter. So we have 22.5 inches. And we want to set that equal to a proportion where it's 8 feet. Okay, 8 feet though. How many inches is that? That's going to be 12 inches times 8. So that's going to be what, 96? So it's 96 inches tall, the real model. And we don't know what the diameter of the real thing is. Okay, but this is the proportion that we would use to figure it out. So this would just be a matter of cross multiplying. So it would be 20 times x, which is 20x, equal to 22.5 times 96, which is 2160. Now at the end of the day, we would be dividing by 20, so that would become x equals. Okay, find the value of mn. Mn is right here. If AB is 21, I would definitely label that. AB is 21, cool. BC is 16.8, where is that? That's over here. 16.8. And finally, LM is 28, so this is 28 right here. And we know that ABC is similar, that symbol means similar to LM and O. So what that means is the side lengths are proportional. The side lengths are proportional. So notice how we're trying to find the red one, which we're going to call x. Okay, that's ultimately what they want, right? They say, find mn. Well, we're trying to find this. Do you see how the red one, this x that we're trying to find, that's between the double rainbow angle and the single rainbow angle? And we have this single rainbow angle and a double rainbow angle here. So this side length x has to correspond with 16.8. Now, it doesn't mean that x equals 16.8. It just means it corresponds with 16.8. Similarly, do you see how this side that's 28 units long is between the double rainbow and the triple rainbow? Well, that corresponds with this side, which is also between the double rainbow and the triple rainbow. So you could actually set up a proportion, okay? We're going to set up a proportion that pertains to the large shape, and we're going to set up a fraction that pertains to the smaller shape. And, you know, one way of doing it is like that, okay? And here's one way of kind of understanding what's going on. And then you could say there is the anything that's between the double rainbow and the single rainbow, we're going to make red. Okay, let's make that red. And anything that's between the double rainbow and the triple rainbow, we're going to make blue. Okay. So this is just one way. You don't have to always draw this table, but I just want to illustrate the sort of thought process behind it. We're going to put red up here, and we're going to put blue down here. Now, the red, as it pertains to the large shape, would be x, right? That's going to be x over the blue, as it pertains to the large shape, which is 28, okay? And that's going to be a fraction that's set equal to, this other fraction. So the red, as it pertains to the small shape, is 16.8. And then finally, the blue, as it pertains to the small shape, is 21. So that's a way of conceptualizing how to set up the proportion. Now, the reality is that I could have done red, blue with SL. I could have done blue, red with LS, and I could have done blue, red with SL, okay? But as long as this is sort of straightened out, you know, as long as it's kind of organized in that fashion, you're good to go. So we're going to have x over 28 equals 16.8 over 21. Cross multiplying would give us 21x equals 470.4. So 470.4 divided by 21 is 22.4. So that's this one. Okay, let's see. Looking at problem number 30 for f of x equals negative 4x plus 2, find f of x when x equals 1. So very easy. You're just finding f of negative 1. And that's going to be a matter of just substituting negative 1 in for x. Okay, so we have negative 4 times negative 1 plus 2. We're going to have 4 plus 2, and that's going to equal 6. And then we are done with that one. Okay, so which of the following could represent three consecutive integers? So consecutive means like one after another. Here's an example of consecutive integer, 1, 2, and 3. Here's another example of consecutive integers. It could be 1, and then 3, and then 5, where it's sort of spaced out by 2 every single time, okay? So which of these could be that? Well, probably not this, because you have x, but then 2 units later, you have the one that comes after x. So that seems wrong. B is correct because that is most definitely the structure that we're looking for. You have some number, and then the next number is just 1 plus the old number, and then this next third number is 2 plus the original number, right? So this is consecutive right here. Let's see, which of the following could represent three consecutive even integers? In other words, you're going to add 2 each time, okay? So let's see. I would say answer choice D, because if it's even, you start with an even number. Let's say y is 2, and then you add 2 to that, and then you're going to get 4, and then you add 4 to the original number, and 2 plus 4 is 6, so that's going to be that one. All right, that's consecutive even integer. Okay, this was consecutive odd that I gave you before. This is regular consecutive. So when they say consecutive, now that I'm looking at it, it looks like they're referring to just regular consecutive, where you're just adding 1 each time. Consecutive odd would be this, consecutive even would be this. Problem number 33, which of the following could represent three consecutive odd integers? Well, once again, you're going to be just adding 2 to each of the things. So let's say Z, you started with an odd number, and then you add 2 to that. You're going to get another odd number, and then you're going to add 4 to the original number. Well, guess what? You're actually going to get another odd number. So odd numbers go up by 2 each time. I mean, you can clearly see that. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So answer choice C is the answer to that one. The sum of three consecutive even integers is 54. Which equation could be used to find? Well, it's the sum of three consecutive even integers. So you have the first even integer plus the next even integer, right? Plus the next even integer. And that apparently equals 54, right? In case you're wondering where I got this from, well, essentially I got it here, right? They said, which of the following could represent three consecutive even integers? Well, they used y, I used x, but whatever. Basically, you just have, this is the first one, this is the next one, and this is the next one. Well, that's what I did. Here's the first one, and here's the next one, and here's the next one. And since it's the sum, we're adding them all, right? Now, you could actually drop the parentheses because there's an invisible positive 1 in front of each of those parentheses that if you distributed it would just drop the parentheses and keep the values the same. You could then recognize that you have like terms. You have an x, you have an x, you have an x, you have a 2, you have a 4. So that's going to become 3x plus 6 equals 54. And then that could be used to solve for x. Now, x would be the first number in that list of three consecutive even integers, right? So x would be the first number. You could use that. So we're looking at answer choice A. Answer choice A could be used to figure out the integers. So the sum of the four consecutive odd integers, 64, what's the smallest of these integers? Well, we're going to do the same thing. So we're going to say, here's the first odd integer, plus the next odd integer, plus the next odd integer, plus the next odd integer. That's going to be x plus 6 this time. And that's going to equal 64. So combining like terms gives us 4x plus, okay, we have 12. And that equals 64. Subtracting 12 from both sides would be 52. Dividing both sides by 4 would be 13. So 13 is the first odd integer in that list. Here's one odd integer, here's the next odd integer, here's the next odd integer, here's the next odd integer, and the first odd integer is x, and we just found out what x was, so that's the smallest of the integers, so that is indeed A. Problem number 36. Let's see. The product of two consecutive integers is 30. Which equation could be used to find? Well, that would be x times the next one on the list, which is x plus 1. And that's going to be equaling 30, because when they use the word product, that means multiplication. That means you're taking the first integer and you're multiplying it by consecutive integer, which is the next integer on the list. Not consecutive even, not consecutive odd, but just consecutive integer, which means it's going to be x times x plus 1. So that's going to be the equation that could be used, and that's answer choice D. Okay, so looking at problem number 37. Paul took 3 tests. His grades were 92, 85, and 87. He will take one more test before the end of the semester. If he wants a test average of 90, what must he score on the 4th test? Well, average is going to equal the sum over the number of values. Number of values. Okay, that's the average formula. So in this case, we have a target average of 90. We want a 90 as the average, and that's going to be after how many tests? 1, 2, 3, and a total of 4 tests, right? Now, what did he get on the first test? He got a 92. What did he get on the next one? He got an 85, so we're going to be adding that. What did he get on the third one? He got an 87. And we do not know what he's going to get on that 4th one, so we're going to call that x, right? So at this point, we can then, simplify both sides of the equation. We'll keep the 4 down here. 92 plus 85 plus 87 is 264 plus x. And then when we multiply both sides by 4, because that's what we have to do to get rid of the 4 down below, these would cancel. Next thing we know, we have 264 plus x equals 90 times 4, which is 360. Subtracting 264 from both sides would give us x equals 10 minus 4 is 6. 15 minus 6 is 9. So we would get 96. He would need a 96 in order to get the target average of a 90. Okay. So answer choice C. Let's see. A set of 6 numbers has a mean of 12. What is the additional number that must be included in this set to create a new set with a mean that has 3 more than the mean of the original set? So before we had 6 numbers, and when you added all 6, you have the sum of 6. And then when you divided by 6, you ended up with that original mean of 12. Now, mean means average, okay? So you have the sum of 6 divided by 6, and that gives you 12. Now, what that means is if you, and you can see this by multiplying both sides by 6, which would cancel those 6s, which would cancel the 6 in the denominator, you would quickly see that the sum of the first 6 was 72, okay? So that's going to be helpful information because we don't know what the 6 numbers were necessarily, but we do know that when you add them all, you're going to get 72. Now they're saying, well, we want to create a new set with a mean that is 4. Oh, here it is. We want to create a new set with a mean that is 3 more than the mean of the original set. So 3 more than the original mean is 15. So the new target average is 15. And that's going to be a matter of dividing or adding together 7 total numbers, right? We could say there's the sum of the first 6, sum of 6. That's the first number we're adding, plus this new number, and we're going to be dividing that by 7. And then we're hopefully going to get this new average, which is 15. That's essentially what they're saying. So we already know what the sum of the first 6 is, however. So we know that the sum of the first 6 is 72. So it's really going to be 72 plus x all over 7, and that's going to equal 15. At that point, we can then solve for x. We can multiply both sides by 7. That would cancel the 7 in the denominator. And then from there, we would quickly see, okay, fine. So we are looking at 72 plus x over here. And then 10 times 7 is 70. 5 times 7 is 35. 7 plus 35 is 105. So then subtracting 72 from both sides would give us 5 minus 2 is 3. 10 minus 7 is 3. So x would be 33. So that is that is the new number that we could bring into the fold that would create a new average of 15. So the answer to that one is B. Looking at problem number 39, a set of 9 numbers has a mean of 20. So already we have the sum of 9 divided by 9, and we know that that equals 20. What is additional number must be included in the set to create a new set that has a mean that is 4 less than the mean of the original set. So already we're looking at a target mean of 16. That's going to be the result of dividing by 10 numbers. We know it's going to be the sum of the first 9 plus the new number divided by 10 is going to give us the new target mean of 16. So this is literally the exact same process. So at the end of the day, we know that we can find the sum of the 9 right away. We could do so by multiplying both sides by 9. That gets rid of this denominator. Next thing we know, we have the sum of 9 equals 9 times 20, which is 180, I believe, right? So we could fill that in over here. It's really 16 equals 180 plus x divided by 10. At that point, we could multiply both sides by 10. And then we have a scenario where it is 180 plus x equals 160. And after subtracting 180 from both sides, we end up with a negative number, which is negative 20. And that makes sense because we're adding a new number that brings the average lower. So negative 20 should be the answer, and that is right here. Okay. Lori has taken 4 tests so far in her math class. Her scores of these tests are blah, 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 blah. The score on her final exam will be counted twice in her mean. What is the lowest score she can get on her final exam to have a mean score of no less than 92? Okay, so when they say no less, that means that, I'll put the target score on the right, and we're going to have everything else on the left. Well, we want the average over here to be no less than 92. So what that means is the average has to be greater than or equal to 92. So just get used to the fact that the phrase no less means this thing is greater than or equal to 92. If they were to say something like no more, then this thing would be less than or equal to 92. Okay? So these phrases you might need a little practice with. Okay, now in reality, she's taking a total of 5 tests, so there's a temptation to just say that, oh, we're going to divide by 5. But the thing is we have a scenario where that final exam is being counted twice. So it sort of amounts to a scenario where it's almost like you're taking 6 tests, if you think about it, okay? So really, you can think of it as taking 6 tests. So it's going to be the sum of the first 4. We have 94 plus 100 plus 88 plus 80, and then it's plus x, which is the score of the final test, plus another x, because that score is getting counted twice. So I would say simplify both sides of the equation before you do anything else. So let's go ahead and add all these 4 numbers, 94 plus 100 plus 88 plus 80, and that would turn into, let's see, that would turn into 362. So we're looking at really 362 up top. 362 plus 2x. So I think you would agree that x plus x is really 2x. And then we have all over 6, and that is greater than or equal to 92. And at this point, I would multiply both sides by 6. And as a result of multiplying both sides by 6, these would cancel, and that would give us 362 plus 2x is greater than or equal to, that would be 552. Subtracting 362 from that would be 2x is greater than or equal to, looks like it would be 0. 15 minus 6 is 90, 190. And then dividing both sides by 2 would be a matter of, 2 goes into 19 9 times, or 95. So x has to be at least 95, okay? So that's the answer there. So let's see. After 3 tests, Brandon has a test average of 90. After his 4th test, his average dropped to an 85. What did he score on his 4th test? Okay, so you had the sum of the first 3 divided by 3, and before that gave us a 90. So already we know that the sum of the first 3, sum of 3, was 270, right? But then all of a sudden, we have a new scenario where we have a new average. The new average is now 85. So we're going to just write that, 85. And that's after 4 tests. And that's going to be a result of the sum of the first 3, which is 270. I'll actually keep that in green. 270 plus the new test. And the question is, well, what is this new test here? Okay. So what we could do is multiply both sides by 4. Okay, multiply both sides by 4. As a result, that we cancel these 4s. Next thing we know, we have over on the right 270 plus x, and then 4 times 85. 80 times 4 is 320. 5 times 4 is 20. So we're looking at 320 plus 20, which is 340. At that point, we could subtract 270 from both sides. We end up with x equals 0 minus 0 is 0. 14 minus 7 is 7. And then that would be it. So x is 70, so he must have gotten a 70 on that test. All right, so that's how you do that one. Let's see, Daniel scored at least 1 point during each of 5 games. If the average number of points he scored is 10, what is the greatest possible number of points he could have scored in 1 game? Okay, so the average of 5, I guess, games, it was 10 points per game. So that's a result of the sum of the first 5. The sum of the first 5 games divided by 5 give you 10. But we want to know what is the greatest possible number of points he could have scored in 1 game. Well, that would be a result of minimizing the amount of points that he got in the other 4 games. Now, apparently, he scored at least 1 point in each of the games. So the minimum number of points he could have scored in the first 4 games is 1 point for the first game, another point for the other one. It's basically 1 point for each of those 4. And that's going to maximize the amount of points he had to score in the 5th game in order to still get the average of 10, right? So what is the value? Because we're looking for the greatest possible number of points he could have scored in one of the games. Well, that's going to be a matter of minimizing the amount of points that he scores in the other 4 games. Okay, hopefully that makes sense. So we end up with 10 equals really 4 plus x all over 5. Multiplying both sides by 5 would give us, if we bring it over here, it would give us 50 equals 4 plus x. And then we have x equals 50 minus 4 is 46. So it's possible that he scored 46 points in 1 game. So he had an amazing game where he scored 46 points, and then he's just scored 1 point in all the other 4 games, okay? You would still get that average of 10 points per game. So we're looking at answer choice C. Looking at problem number 43, if the mean of blah, 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 blah is 30, what is the value of that? Okay, so apparently when we take x plus 2x plus 3x, and then we divide that by 3, because that's 3 total numbers, that's going to be 30. So the question is, okay, what's x? Well, we could just solve this thing. I would say go ahead and simplify both sides. 30 equals, looks like that would be 6x over 3. You could then multiply both sides by 3. You're going to end up with 90 equals 6x. Divide both sides by 6. X equals 15. So that's the answer there. Okay, the mean of 4x, 5x, and 6x, I guess that's a 90. Pretty sure that's a 90. What's the value of x? Well, it's going to be the same thing. 90 is the average. That's a result of dividing by 3 numbers. We're going to have 4x plus 5x up top plus 6x up top. So at the end of the day, if we were to simplify that, that would turn into, let's just draw a little divider, that would turn into 15x divided by 3 equals 90. Multiplying both sides by 3, we're going to get 270 equals 15x. And then finally dividing both sides by 15 would give us 18. So x is 18, which is all they ask for, right? Notice how they did not ask for the value of each number, right? They only asked for the value of x, which we just found, right? But you do want to be careful. If they had asked me what the value of each number is, I would have had to take 18 and plug it into this, this, and that. And this would have been 4 times 18, this would have been 5 times 18, this would have been 6 times 18, and those would have been the answers. Okay, so looking at problem number 45, the product of 2 consecutive positive integers is 72. What is the larger of the integers? Well, that's going to be x times x plus 1, and that equals 72, right? That equals 72. Well, there's a way to solve this that's beyond the scope of, I'm not sure why that says 11, that should just be x plus 1. There's a way to solve this that's beyond the scope of sort of 8th grade algebra. But so I want to stay away from that. But I would say the guess and check way, or even using the answer choices, is a decent way. I would say maybe even just scrap this. Let's imagine that the larger of the two numbers was 9. Well, that means that you would have had to multiply 9 by the number that's 1 less than 9, which is 8, right? Would that give us 72? Yes. That's why answer choice B is the answer, okay? Two consecutive positive integers, when you multiply them because it's the product, it's going to be 72. What's the larger of the two? Well, if the larger of the two is 9, then the one before that is 8, and certainly 9 times 8 is 72, so you're done. All right, that's the best way to do it at this level. Okay, so the product of three consecutive odd integers is 105. What's the middle integer? Once again, they're talking about products, so they're talking about multiplication. Similarly, I'm going to say let's go ahead and just plug in the answer choices and find out which one would work. If there were no multiple choice, I would say at this level of the game, you might have to guess and check. All right, but we're going to plug in the middle, the answer choices, and see which one is the middle. So if it's answer choice A, well, then the middle one would be 5, which means the next one would be 7, which means the one before that would be 3. And then the question is, okay, when I multiply 3 times 5 times 7, do I actually get 105? And it looks like you would. It looks like you would. So actually, answer choice A is the answer. So when it comes to these, you just have to use the answer choices. Just basically imagine if answer choice A was correct. If answer choice A was correct, well, middle number would be 5, so there it is. And the next one to the right would be 7, the next one to the left, or the one that's before it to the left, would be 3. You multiply them all because it's a product, and just see if it would give you 105, and certainly it did. All right, so that's how you do those. Anyway, very long video. Hopefully you guys got something out of it, and I will talk to you later. Take it easy.